the massive amount of applications that we're receiving right now. I think we're at about 900 applications received worldwide. And then we have obviously people who are willing to provide mentorships. And on 31st December, we are hoping to sort of announce all the top teams. And these are tentative deadlines. Don't hold me on this. And also NMM probably. And finally, we'll have the showcase of all of the top solutions during the week of the Impact Summit, which is 16th to 20th. And on the day of the sort of Impact Summit, we are also hoping to have a separate investor roundtable for women-led solutions. The next slide, please. And yes, again, this is an open call to partner with us in every capacity that you can. And yes, with that, I would sort of end my speech. Thank you so much. Yeah.
You can use. Do we have any questions? Regard.
Submit.
I mean, as long as your designation is, if you're heading a product team, then your designation should be sort of fine. You just define the designation. If you need any additional documents for proof, we can ask for that. But
Okay, so I mean, not from the company perspective, right? If they are having their own entrepreneurial journey and they want to.
okay, that's great. I mean, in that case, as long as you're developing independently, we don't need anything from your company except a NOC saying that they have no problem in
Okay.
sort of, yeah.
So is there any template? Because we just browsed to the site. I think there was nothing like
No,
NOC.
no template is required. You can, I mean, any generic NOC template would work.
Okay, okay.
Right.
Yeah. Thanks.
No worries. Any more questions? Yes. Yeah, that's a good question. Actually, for AI by Her, it is from POC to scaled solutions. For AI for all, it is only sort of piloted solutions which already have been piloted or scaled. But AI by Her is from POC, from lab to sort of deployed. So let's say a TRL4 to TRL9, right? The entire spectrum is accepted except idea stages. Idea stages is mostly for the youth sort of UII hackathon. Yes, you can apply, but before you are sort of, if you are selected, by that time you must have a registration in DPIIT. Yes. Through DPIIT. Yes. So actually, there is a website in impact.india.gov.in. If you go browse there and go into AI by Her, you will be able to see a detailed form. It's a very intuitive form. It should not be an issue filling it up. No, 16 to 20th, there'll be no evaluation. At that time, the top 10 has been selected. Right. By that time, yes. Yeah. We see. Different. Yes, ma'am. Yes, ma'am. Ma'am will be able to give more insight into that. Any more questions? Yes, please.
of the summit, where they showcase their solutions and other aspects. So a more long term thing where we would need really stakeholders to come and join hands with us, and WEP being a stakeholder, it enables stakeholder consultations and bringing stakeholders together to have programs where everybody kind of pitches in. We are in that role where we think we will be able to take these forward beyond the summit as well. And today, while there were a couple of goals for today's event. First, to tell about AI by her and get the students and other startup community in Bangalore interested in applying for the challenge, inform them about the summit, and also create necessary momentum in the city. Though we don't need to do it, but still to come to the city and spread the word and get them associated not only to for the AI by her, but the other two challenges and several other things which Anurag today presented. And lastly, also to mobilize the community to come together so that we join hands and it does not become a one-off event where we just recognize some teams, give the award money and be done with it. The idea is we take it forward to some logical conclusion, and that is why today we have invited uh, companies like Bosch representatives are here. We have invited Accenture, though I don't see many people. I don't know whether it is the Bangalore traffic or I don't know why. Monday blues or the reason is not clear. But irrespective of whether people are here or not, we are building this community to help us handhold these women innovators and take them forward in their journey of development and deployment, because that is my firm belief that development, the tougher thing is deployment, where you need much more hand holding and other partners to come together. So the AI by her is a little bit different from the other two challenges, and I got it from my team so that I don't make any mistakes. So I'll just read it out. Please bear with me. A woman founder or a co-founder in a decisive role such as CEO, CTO, or COO, or a team with at least one woman in a core role like technical, product, or business lead can apply. Teams may have up to 3 members, with at least 2 women representing at reviews, boot camps, and the summit showcase. Eligible applicants include registered companies, startups, MSMEs, non-profits, public or autonomous bodies, and academic or R&D institutions.
is helping us design this today event, and Samita Nasco is also helping us with the single shop. Nasco will also be
मैं थोड़ी देर में आपको कॉल करूं
both Aarti and Samita are here today.
that in nature, bacteria seem to have a set of proteins that can make very precise identification of any sequence that you really care about in a genome. So this system exists naturally inside a bacteria. It's a set of protein and a nucleic acid called an RNA, which forms the CRISPR machinery. Obviously, scientists have taken it out and shown that using this particular machinery, you can target any sequence of your choice inside any genome of interest, be it human, be it other organisms, plants, other bacteria, viruses, etc. And the precision is so high that it can actually even discern single base changes in this 6 billion genome. So that's the power of this synthetic biology. And that's the machinery called CRISPR. Once it identifies the genome or the sequence of interest, what it does is actually it conducts a snip or a cut into the genome. So now you imagine you have a really powerful tool that can recognize even one base change that you really care about, and you can make a cut. So once you make a cut, you can now do anything with the genome of interest. But how do you make a cut? How do you identify what it is that you need to be editing or cutting? So at CRISPR Bits, we are a 5-year-old startup company founded by 5 distinguished alumni from BITS Pilani, including Professor Vijay Chandru, who was professor of computer science department here at the Indian Institute of Science, and very closely associated with ARTPARK as well. So he is also the CEO of CRISPR Bits. Now, at CRISPR Bits, we have taken an approach to actually building a platform kind of approach using this CRISPR technology. And I'll talk to you about 2 of the platforms, one from the editing and one from the diagnostic, and how we have brought in AI with CRISPR to try and enhance the power of these platforms. Can I go to the next slide? So the first platform that I'm going to be talking about is actually PathCrisp, or our diagnostic platform. So what we realize, the work we do in biology it's obviously biology is complex and not a problem that we have yet solved. And there are patterns in large data sets that AI can actually recognize, which is beyond our conventional statistics method. So this can dramatically accelerate our R&D, and to what extent? So, for example, as I talked to you about, what the CRISPR machinery is, right? How do we design that targeting a small section of the genome? And this is where we actually use AI in our what we call as the guide design engine. So how you scan the genome, how you find the perfect, if you may call it, the signal to be able to say that this is exactly what I want to precisely edit. And we have a machinery built at the back end where data from the lab fits back into the model that we have for better and better design. We'll talk a little bit about it. Another place where we are using the second platform, which is, so this is our PathCrisp platform, and the application that, the most strong application of this we are right now is building an ICU detection on point of need detection for antimicrobial infections, resistance infections. We'll talk about it a little bit more. The other platform that I want to talk about is on editing strains or not pathogens, microbes for better bioproduction, biofuel, using starting from bagasse, starting from different sewage material, or so on and so forth. And this is another area where we feel that AI has a very strong role to play, and we are adopting it in developing the platform. So, next slide. Okay. So as you know, the first platform that I talked about was our diagnostics platform. We call it the PathCrisp, for accurate detection of AMR and pathogens and basically infectious agents. So AMR, as you know, is known as the silent pandemic right now of the global south. Yeah. Okay. Hi. Sorry. So 47% of the population lacks basic access to diagnostics. And if you could reduce this gap even from 50% to 10%, over 1 million deaths in LMICs can be prevented. So this is our simple path platform, the path crisps, and the chemistry is in the middle where you have the sample in which you have the bacteria, the human cells or the bacteria. You can do a crude extraction, and then in a tube you can actually run the CRISPR assay and you get a signal. Front end and back end of this platform we have is complemented by AI. The guide design engine that I talked to you about, which helps us design this CRISPR assays by scanning the genome and exactly picking up the sequence that we need to target. Now, as you can imagine, if you want to sequence, if you want to target a particular sequence, there could be mismatches, there could be off targets. How do you deal with all this? I'm not getting into the depth of it, but that's where we have the design engine to help us guide design. As and when we keep building more and more assays, we feed that back into our guide engine in sort of a reinforcement and to help us design better from what we actually learn from the data in the lab. At the front end, the data is now automatically stored in the cloud, and there's a software that triggers the analysis. And even smaller steps of our operations, which we are trying to use AI. For example, this is our assay, as you can see, a lyophilized powder, which is our CRISPR assay. And we build these in the lab, right? Our manufacturing unit builds this. We have a small AI tool, we are trying to develop where we can actually scan through these and say that, which one needs to go into our kit, which one needs to be discarded, etc. So smaller parts like this, uh, also in the operations of this platform or developing this kit where we have actually used AI. The value proposition of the kit is a highly accurate, within 3 hours diagnosis, easy to use, instrument light test for detecting AMR and pathogens in the ICU. Next slide, please. And antimicrobial resistance. So pathogens develop certain resistance markers which render them, uh, immune to antibiotics. So this is an opportunity and a challenge for solving the problem. As I told you that there is a lot of data. So what we have built is the diagnostic or the assay test that can detect AMR. We believe that augmenting this with information, electronic medical data, and ICU notes on top of this assay, that can actually give us better prediction and more accurate diagnosis, guiding what needs to be tested. But there are certain challenges. AI is data hungry. Right now, we don't have a structured method anywhere in the hospitals to collect this information. So we are trying to do this through the studies that we run as we validate these tests. And then there'll be biases in the data, right? Certain hospitals will have it. Maybe the hospitals like Apollo's and Manipal's, the richer ones, but the poorer ones will not have it. So you will lose out on that data. But the data is there in the government hospitals. I mean, that information is equally important. So how do you make sure that there's no bias in the data? Then there is also poor incentive for AMR itself is not a problem that everybody wants to put money in. Neither is AI. So how do you get somebody to fund building or augmenting a platform on something where individually neither of them are being considered sort of financially a big hit? Uh, and then of course we will talk about a little bit of policy changes that we would really like. There's no clear path for these approvals. There are stakeholders. One Health is a big problem. So some of the problems exist in the One Health situations where, that now we know that there are these pathogens that and AMR that can easily move from animals, from farms, from sewage, from community setups into patients and into hospitals. But how do you gather that information from these fragmented stakeholders? And most importantly, the pace of AMR far outpaces AI. So by the time you put all this together, build a model, AMR has gone to the next stage. However, it's still a very big problem given this is AI and her session. Bacteria does not follow gender, but society does. Women are more likely susceptible to antibiotics resistance. And, there are a lot of problems which women go to hospital with, UTI, childbirth, which is very health specific, and greater exposure as a caregiver and a frontline worker. So which is why this is a major problem. Next slide, please. I'll quickly switch over and talk to you about the other platform, our strain engineering platform or editing platform of microbial editing, where we are using synthetic biology again to edit and change these organisms. And I want to talk to you about how we are using AI in wanting to build this. So obviously the design for these edits, as I told you, it has to be guided by AI, particularly, mining through literature, existing literature from large language models, looking through large data sets, predicting phenotype outcomes, by how much percentage do you think this particular lactose production or this amino acid production will be enhanced, or, so things like that. So what is, would there be an off-target effect that will create toxicity if we do these predicts? So these kind of predictions absolutely need AI as the backbone of the strain engineering platform. Equally important is building better CRISPR tools, like, we have certain Cas enzymes which naturally occur in nature, but today we know that AI has given us the ability to develop better enzymes, and that is another we would like to integrate into this platform. And very importantly, strain engineering is not a problem of a single bacteria. Bacteria and exists in communities. So when you edit, you have to consider editing an entire consortia of bacteria. Now, if you need to edit, let us take a step, like say you have to hydrolyze certain cellulose, and go to the next step of the simple sugar. It is not a single bacteria. So what is the percentage in which these bacteria need to be, which one, by how much? This is not a trial and error. If you were to do this trial and error, this will not work out. Next slide, please. So the are plenty, making new biofuels, biogas, looking at effluent and waste treatment, bioproduction of certain amino acids, sugars, and other important vitamins, etc. All of these require strain engineering, and at the core of it is you design using AI and simulate. You build in the CRISPR lab with automation, test it, learn, and feed it back into this particular cycle. Here's an example of what I was telling you about. This is effluent treatment. And as you can see that there are 5 different steps, from degrading, nitrification, denitrification, producing methane, removal of phosphate, anaerobic digestion. So these are all the steps, and each one by a consortium of bacteria. So not only do you have to figure out what to edit in the bacteria, which particular gene or pathway, by how much, you also have to figure out how to make it survive in that community. And this is not a problem that can be solved without using AI as the backbone of building such a platform. The challenge is data is the key. Sieving through multiple types of data, resolving conflict, talk about one kind of data and another publication talking of exactly the opposite. How do you resolve those conflicts? And then obviously something like this is going to generate you thousands of hypotheses. How do you test it? So you need to build automation in your lab or in your process to be able to test all those hypotheses and feed back that information into your model. Next slide, please. So, what are the policy changes for somebody in synthetic biology, and to make this more effective is, I think there has to be a single body that looks at approvals and policy changes and regulatory, which looks at deep tech, both from AI and synthetic biology. If these are in desperate situation, in desperate hands or desperate committees, the results will be very different. We have to incentivize AI innovation in synthetic biology with funding, with infrastructure. As I said, this requires a lot of infrastructure. Need a sandbox kind of approach to be able to quickly launch with new ideas and proof of concepts. IP policies need to be looked at. India has an IP policy where algorithms, I do believe, are still not easy to IP. But if you're getting so much into the application of AI, how can small startups or innovators actually put it together unless you have a relook at the IP policy, where you will be able to IP your entire platform, AI plus the synthetic biology plus the chemistry, skill set development, of course, and then we have to harmonize this whole thing with the regulatory policies at the international standard. Next slide. My last 2 slides. Do women have a specific role to play? Why AI and by her? Yes. There's about 25% of AI scientists, about 20%, which is not a small number of scientists, computer scientists looking at AI in amongst women. And there are about 45 to 50% of them. Of course, a fraction in the industry, but there is obviously a disparity on the two sides, and women talk better with each other, integrate better. So there's a way to bridge disciplines. collaborate over competition, and collective thinking, teamwork, which are all strength of her. And there is a better look at safety standards, bioethics, and collectively we can bring focus on a lot of One Health and public health problems, particularly pertaining to infant mortality, maternal health, and particularly climate resilience and problems of underserved communities. And my last slide, please. And climate and health, these are not gender neutral problems, and women bear the deepest scars, and hence we have to build the strongest solutions. Thank you. Next slide. This slide. Yeah, that's the team. That's our founders, Professor Chandru, who's here, Sunil Arora and Aditya, who have been very kind and mentoring and helping us. And that's the team at CRISPR-Bits. We are in Hebal, in the US Alumni Building, just a few kilometers from here.
Thank you, Dr. Vaijayanti, for the very informative and insightful presentation. Dr. Vaijayanti, if there are any questions for Dr. Vaijayanti, okay, we'll do it towards end. Okay. Okay, the next speaker for this session is Ritu Mehrotra from Shunya Labs. Ritu is a technology entrepreneur and CEO of Shunya Labs, a deep tech speech and language AI company spun out of her previous venture, United We Care. She has built a career at the intersection of high growth startups and global tech led enterprises. With earlier leadership roles in global firms, most notably at Booking.com and Zomato, Ritu brings deep expertise in growth, operations, and scaling businesses across geographies. In founding United We Care, she focused on improving access, affordability, and quality of mental health support through generative AI, building a multilingual virtual coach and a global clinical knowledge graph. With Shunya Labs, she now leads the development of a world-class automatic speech recognition engine optimized for CPU or edge deployment in more than 20 Indic languages, continuing her mission to democratize AI-powered health and wellness support. Beyond business, Ritu is also a cancer survivor and advocates for using technology in service of human well-being, emphasizing ethical AI, privacy, and global impact. Over to Ritu.
Thank you very much for warm intro. Hi, everyone. As you already know now, I'm Ritu Mehrotra, founder and CEO of Shunya Labs and United We Care, the two companies. Maybe I'll walk a little bit. Perfect. So just a little introduction, and maybe we could go to the next slide if possible. Started off Shunya Labs a year back, but the reason behind that is, before starting, a quick introduction, I used to head Booking.com Asia for 30 plus countries. So product, technology was all kind of led by me for all these 30 countries. And before that, I was with Zomato. And I had my own startup called Green Plate in the Bay Area, which is about 8 years back. Seems like history now. The reason I started that company was I'm a cancer survivor. And after surviving cancer, you want to do something for the world. And one of the issues that world faces today is at least the United States would consume few billion donuts a year. But if you go and look for healthy meals, they were not enough available. So the company was about delivering organic meals to corporate America. But what I did not realize is that, life take different turns. And while I recovered cancer, I went through my own mental health journey. And that was far more deep than even surviving cancer. And what I realized was that after, when I would seek for support, like a therapist in the US, which is such an advanced country, I just couldn't find support, the language, time to care, context to care. I would get an appointment with a clinician like 2 weeks out, and I would get anxiety attacks at night, right? Would not find anybody. So, long story short, I shut my company. I wanted to be back with my, parents and my family in India, and that's where I worked with Zomato and Booking. But when COVID hit, I found the first opportunity to actually work on, building better mental health solutions, because there are not enough clinicians in the world. So, can we go to the next slide? So, so that's me and my co-founder. I already shared about the story. So, a slide later. So while I was building an AI therapist, I very quickly realized that today's sensors, right? Anything that AI understands is voice. And the voice was not so AI therapists just wouldn't understand if my mother is talking to an AI therapist. Idea was never to replace an AI therapist with a human therapist, but idea was that preclinical subclinical needs could be addressed with with having an AI expert in between, right? But it would just not understand context, long, short window, which I think a lot of you in AI would understand, that if I've spoken something a few weeks back, it would just not remember, and the medication. So we realized that no, if we have to build a context and conscious therapist, psychiatrist, it is important for us to make them understand our language. And we speak in English. We speak in multiple different languages, which AI was not able to understand. We looked at solutions that existed, Google and Nvidia, because we are an AI company ourselves. So we wanted to pick up these open solutions and build something on top. We couldn't find anything. So after multiple iterations, we actually thought we'll build our own, and we did it. So as you can see, all the AI models that exist today in the voice infra, they lack precision, they're not accurate. So especially that's why the AI, we say that technology takes longer in the medical field. It's precisely because it's if it's not going to be accurate, doctors will always hesitate to kind of use and utilize it. So lacks precision, it's not context aware, GPU dependent, very expensive, scarce, we all know that. Cloud heavy, English first. It's just 20% of the population. While there are companies like Servam, etc., that are building even for India or Asia, but there is still long, long way to go. High latency. So if you're talking, if you're making a conversation with an AI, you are expecting a response right there, which is thought through. And privacy is unmet because a lot of it is on cloud. So if you look at what's happening globally, 60% of voice searches, 60% of searches happen on voice. And if you look at rural parts of the world, including rural India, a lot of people do not know how to write and read, but they know how to speak. So we are at a cusp, we are at an inflection point where we can actually change the way we operate and we interact with AI for a greater good. And that's the problem, a large piece of problem that we are solving now. And these are known problems. The moment you start developing and and you start talking to people, there are even deeper problems. I'll give you an example, right? So when we were looking at how to build our own model, we looked around, people are talking about billions and billions of parameters, billions being spent on building something like that. We are a small startup. We had only raised $5 million. We did not have that kind of money. So we built our own technology. Yeah. So we have a research lab wherein we said, and just to give an example, if there is a new 5-year book that I give to any one of you today, which is a new book in the market, and if you read it, you're not going to learn anything new. Goes back. If anybody has smartphone and you type ChatGPT to show 625 on an analog watch, it will not be able to show you. It will show you 1010. Why? Because you keep feeding data after data, billions of parameters of same data. So you have overrepresentation of certain data sets and you have underrepresentation. Like 625, a lot of people, all the clocks that you see in the globe, will show you 1010, right? So we realized very quickly that, more data is not cool. And so we created a technology where we started to prune the data, but we introduced high entropy data, right? In this parlance, having 625 or other whatever, it's a crude example, but similar data sets we started to include. And that's our own inbuilt research that we worked on. Even today, noun detection. So people talk about word error rate. Oh, I have the best model. I have done it on multiple data sets. My word error rates are fantastic. But hey, they don't detect proper nouns. If I'm actually prescribing a medication and I'm talking about Desvela vaccine and a cutie pin is typed as cutie pie, even if the 90% was correct or 95% was correct, but that 2% means life and death, right? So smaller nuances around building these kinds of models was at the forefront and what we were dealing with, because we were working with US government, by the way. So our AI therapist was already launched with Australia, US, multiple hospitals in India, Fortis is using it, and so on. So we went deeper. So, few layers deeper in proper noun, shorter sentences. If I'm having an anxiety attack, I'm not speaking multiple sentences, right? So I'm going to speak something short, and AI needs to get context and understand it, right? I'm speaking with another customer and they were saying, if I'm talking about a number, it's very hard for AI to understand even today, right? So those were some deeper layers of the problem that we were dealing with, so that the most important sensory tool that AI will need to comprehend humans is, voice, and those are the finer nuances to that. So what we built, as I mentioned, so we built our in-house solution. Our audacious solution is our own ground-up research. We're building a multilingual speech recognition model that runs on any device. So since I said we don't need billions and billions of parameters, it's a few million parameter model that you can actually run on your phone, a kiosk. It may not even need an internet connection. So that's the beauty of it. We It's a very interesting number because I just bashed this number a few seconds back, that the accuracy level is 97%, but from the data sets that you look at, we beat Google, we beat NVIDIA, we beat IBM Parakeet. So these are the kind of players that we, at the global scale, we beat on this day. And this number is, available on Hugging Face, and I'll show you, which is a leaderboard, a global leaderboard. It's the most affordable. You do not need a GPU. It could run on, as I mentioned, any device. So 10x cheaper. So one, it's more accurate and it's cheaper as well. Device and edge. We covered 216 languages and multiple few thousand dialects, right? So I was actually visiting Bhopal and doing a large implementation, and they said there's something very interesting, that even a name like a Sonu is said Sonu, let's say in Madhya Pradesh, and such different things, or Chas, for example, what we call in polluted city that I'm coming from today, Gurgaon, versus, something else in Bangalore. So just having that market coverage and making sure that it's an inclusive platform is what we're building. Under 100 millisecond latency, real time, because we were building for an AI therapist, which needed it to be real time and on-prem. So we built something super audacious in a small investment amount so far. This is the data set. So I'll just very quickly, I know it's not very easy to read this, but just to talk about that, when you talk about voice understanding, voice quality, you actually look at multiple data sets. How is your voice understood in, let's say, noisy background, or during TED Talks, or if it's financial earnings, because the numbers, etc., could be very different. The terminology could be very different. This is us, and this is Canary or Granite, which is IBM models, etc. So it is not, we haven't beaten these benchmarks by a small distance. We've actually beaten these benchmarks by a very large margin, and we're creating our own market from that standpoint. And I spoke about, so we've broken about 7 world records so far. 12 patents, 18 research papers. One of the most cited research paper is by our co-founder, Saurav Banerjee, which is about LLMs will always hallucinate, right? So we're talking about those large language models. Um, the impact. The first thing is, I've lived in Singapore, Switzerland, US, Canada. It just feels proud to be back and doing something for the country. and representing Bharat and building for the world. So today our models are actually being used in US, in Australia, and of course our own country. Groundbreaking research happening in our own country, wherein I don't even know how many companies today are actually building their own models sitting here. Mostly people are actually utilizing these models for greater good, which by the way itself is great, but not many companies, China, when they released DeepSeek, it was such a proud moment for that country and it was all over the place. And here we are, doing groundbreaking research and under $5 million and under 1 billion parameters. People, the whole idea was, and I'll share an example, right? Every time my mom would speak to the AI therapist, and she would struggle to speak in Hindi, then she'll switch to English, then she'll speak in English. Always I saw her and I thought, oh my God, this is how Bharat would interact with anything that is built. And of course, A, she's an inspiration, and also for us to build something which can be utilized by 98% of the population that lives in this country and the globe, eliminates the power for heavy. We know the kind of power usage that happens on GPU, right? Our models actually work on CPU or edge devices. Um, the beauty is, the way I'm envisioning, or the way we are envisioning, is that every time you sit in a cab and anybody who's talking and can sort of share what do you want to do, where do you want to go, what do you want to eat in your own language, and it boom kind of translates into the other language that you want other person to be able to understand. And so empowering those frontline workers wherever they are in India and outside. Our philosophy is very simple, building intelligence that fits where people are, not the other way around. I'll give you another very good example. Our brain actually works at 20 watts power. But you look at all these GPUs, they need thousands and thousands of power that it needs. So our aim is to build something that could possibly mimic one day a brain, which is multiple neurons working in both ways. Hopefully one day that will happen. The challenges, first is data. Label data has been a huge challenge. While Vani, I must say, Project Vani has been such a huge help for us to be building what we're building. But again, labeling has been an issue. Not a lot of is for usage. So need for public partnership, because if we have to democratize speech, it is very, very important for us to kind of come together. And it cannot be a private company also sort of looking at, so Sarvam, for example, is also building their models. So if they are the ones who are going to be looking at us and saying that we are good or not sure how that will work, ma'am. So sorry, I know you didn't mention, but I wanted to still address that. Availability of GPUs, I think the companies that are building ground up research in the country, it's important that we come together and make those GPUs available as well. And for that, we will need government support and pushing for India first. I think that's where we're wanting to go. Do we have more? What India can lead on? We So by the way, when we were building for data sets and voice infra for India, we realized that it's the most diverse voice set. I mean, if I have all the Indian languages I pick, right, and all the dialects I pick, I can solve for any language in the world. And that's the power of, all the 1.4 billion people that live in this country. So support for open representative data sets, as I already mentioned. Incentives for local innovation, I think, is very, very critical. I mean, if you look at China as an example, the kind of incentives that go in, it's fantastic. Not comparing, but all I'm saying is that, it's at the end of the day, it gets down to that. And mandate access standards for digital public infra. And I think that's it. That's what it is. Yeah. Shuna Labs, 8 billion people is what we want to give voice to. Thank you.
If I just make this point, Satnam and EY are building eval criteria. We will be engaging with academicians also. So I understand the conflict of interest thing, but they will not be evaluated. Perfect. So somebody who is developing the criteria cannot be sitting on testing. They are just
Gives us a lot of comfort. Thank you so much, ma'am.
Thank you, Ritu, for such an inspiring and engaging presentation. Thank you. We'll take the questions towards the end of the session. Okay. Next, we have Sona J from CV.ai. Sona is the co-founder and chief design officer of CV, the multilingual AI designer for brands. She is a gold medalist and seasoned design expert with over 15 years of experience. She has worked with multiple startups and MNCs across diverse sectors. She has built and headed successful design teams from the ground up and is also the author of a popular design portal. Over to Sona.
Hi, everyone. Thank you for the opportunity and for the warm introduction. Thank you so much. Hi, everyone. I'm Sona, co-founder of Civi. Can I use this? Am I audible? Yeah, thank you. So, co-founder of Civi. Civi is a multilingual AI designer for brands. So when I say design, you can generate advertisements, social posts, website content, email banners, etc. with Civi. So we would have seen many image models out there, right? So what a design is, it's a composition of text, images, vectors, and colors. So there are a lot of models available for text and image generation. At Civi, we have built a foundational model for design generation because design has multiple layers in that, and there is no data available in the internet for specific for design because it has layers and it has to be structured, right? Even Canva has millions of templates, but they don't have structured data with them. So we have created and curated our own data set, and we built a foundational model, and we built it based on atomic design principles. We have divided the problem into multiple smaller parts, and we have solved each of them individually. So as we all know, like there are text models like LLMs available for text generation, and image models are there for monolithic photographs. So we can like if we ask it to generate a design for an event, it will come up with imperfections in that, right? Like the logo that we add or the brand details that we provide or the text will have imperfections in that. At Civi, we have built a large design model. We don't call it as an LLM because it is about design. We have built a large design model in order to generate layered designs with perfect outcomes. Like every layer in that will have perfection. Like we can feed in the brand fonts, brand guidelines, and everything, and ask Civi to generate with that. So there are a few other research papers like Microsoft has Cole and there is Glyph T5, but at Civi we have built a full-fledged product for that. So with Civi, we can generate designs in 72 global languages, including 23 Indian languages, and we are adding support for more languages. And image models generate designs in specific aspect ratios, right? 1:1 or 9:16, 16:9. But with Civi, you can generate designs in any dimension. You can even specify 361 by 590. It can generate designs in that. So that's with respect to infinite dimensions. And we can set up the brand guidelines once. We can say, these are my brand colors. This is my typography. We can feed in the logo, brand assets, and the components. And Civi can generate, every time we prompt it, it can generate designs within those brand guidelines. And before generating the designs, we can actually control the content that goes as input to it. We can specify this is the exact text message that I want in the design, and these are the images that need to be used in that. And once the designs are generated, just like we edit in any other design tool like Canva or Adobe, we can edit the layers in that. And Civi's model can be trained by enterprises with their data for their use cases. So this is the timeline with which we have built the different versions. We started our prototype in 2022. And in 2023, June, we launched our first version, Gen 1, on Product Hunt, and we emerged as the #1 product. And right now we are building Gen 3, and each model took considerable amount of time because of the number of experiments that we did. Because once the input is given, we pass it to a composer, like we convert that into a representation JSON, and we pass it to the composer. And once the composition is done, we add colors on top of it in order to maintain the brand guidelines. So Civi can be consumed in multiple ways. Like we have a direct web application, which any brand can go like log in, like there's a free usage available as well. They can feed in their brand input. given the prompt and generate designs for their use cases. And there's an API or UI SDK available, which marketing platforms or email platforms can integrate Civi within their platform for on-demand creatives. And as I mentioned, enterprises can train the large design model for their use case. So this is a demo. Will it be possible for you to play that? You can click on it. That's okay. We can skip that and move on. So this is a quick picture of how Civi is integrated within an email platform. So this entire email platform is by another company, and Civi fits in within the AI studio. So every time they asks for a design, it generates and it adds into the email template. So this is a quick comparison of how Civi compares with image models and template tools like Canva. So image models give you, once you prompt it, it gives you an image which you will not be able to edit. Whereas with Civi, we can generate the designs for our use cases. Canva kind of template tools give you a lot of templates. So there will be like Canva has millions of templates. Finding the right template for our use case itself is a challenge, right? And whatever Civi has generated, we can edit every single layer in that. Whereas that's not possible with image models. And as I mentioned, imperfections are there in the image models, which brands will not be interested in using for their final use cases. And we can control it like before generation and after generation, we can control the LLM, like LDM. And with image model, we don't have the control over it. And we can, once the designs are generated, we can export it in multiple formats. We can export in JPG, PNG, HTML, and PDF. And Civi is being used by 120K users, business users from 140 plus countries. And this is with respect to the direct access. And like we have emerged as the #1 product of the week, month, and year in Product Hunt. And the API and the UI SDK is being integrated across different platforms. And we are working with enterprises to train their data for their use cases. So I'm a designer with 14 years of experience. I am a gold medalist. I graduated as an engineer and I worked as a software engineer for a few years. And after that, once I got married, I had a career gap of 3 years. And when I started my career again, I ventured into design. And from there, I worked with multiple startups and MNCs, and I headed design teams. That's when we started, like while we were working with Fortune 500 companies and small and medium businesses, we got to understand that design is one of the major challenges that they had. For example, like we worked with Big Basket in one of the use cases. The marketing teams will work with the creative teams, and they have to wait for 2 weeks to get the creatives from the creative team in order to run the marketing campaigns. So there has been a delay always. So with these experiences is where we started thinking about automating designs for marketing campaigns. So that's the place where we started working on this. Initially, we started working as a rule-based system, and then we ventured into Gen AI, and we started this company much before generative AI was cool. So we are a well-bonded team with the right mix of designers, data scientists, engineers, and marketers. And our mentors have a wealth of experience in technology and in business. So as a team, we have received multiple awards for the foundational model that we are building. So from a policy challenges and recommendations, like one of the major challenges that every AI company or a deep tech company has is compute. So for each version, we spend 8+ months in average in order to like every version gets closer to the human design standards. So like 8+ months, why we spend is because like we have to make the trainings and the data cost effective. So every experiment takes time for us. So with the compute and at a subsidized cost, we'll be able to do the experiments faster and reach the human design standards at a faster pace. So that's one of the major challenges that we face. And when it comes to employment, like as I mentioned, like I had a career gap, and when I started again, I had to start as an intern again, even though I had 3 years of experience earlier. So the people who we have hired, the women in our company, most of them started as interns after a career break, and now some of them are leading the data science teams and marketing. So if there has been a policy where the startups, like especially women founded startups, who we can like from these startups, we can support women who are getting trained as an interns. If some of the cost can be absorbed by an agency or a government, that would be helpful for us to support more women of this sort. So this is one of the second major challenges that we face. And then when it comes to initiatives such as AI by Her and WEP, lot of times what happens is we don't get to know about these information in advance. So like if there can be a process by which we can get to know about it in advance at the right time, that would be helpful for women entrepreneurs to proceed further with those initiatives. Thank you.
Thanks, Sona, for such insightful presentation about your company, the offerings you have, and also the comparison with your competition highlights the effort that you have put in. Thanks. Yeah, next we have Trisha Chatterjee from Immunity AI. Trisha is the co-founder and CTO of Immunity AI, a tech bio company where they have built an AI platform to design novel therapeutic antibodies without any need for existing data. Trisha has been in startup ecosystem working in application of AI in the warehouse and fulfillment space. Since 2020, with her co-founder and tech team, she is building a groundbreaking AI platform which will solve one of the most difficult problems of biotech industry, antibody discovery. Over to Trisha.
Thanks a lot for the warm introduction. I am Trisha. I am the co-founder and CTO of Immunity AI. And as rightly pointed out, we are an antibody discovery, and we've built an AI platform which it can discover novel therapeutic antibodies from scratch without the need of any pre-existing data. And quite interestingly, for this room, we are 100% women-led company. So both me and my co-founder are women working in deep tech and deep sciences. My background is in AI, and my co-founder's background is in biological sciences. And we believe that women can work and lead deep tech companies maybe better than or at par with men. Move on to thank you so much. So why antibodies? So antibodies are present in you, me, everybody in this room, and they have a very special property. Antibodies will go and bind only to their target and nothing else. They have a huge specificity towards their target, and we can harness this power of antibodies. What we can then do is build therapeutic drugs using this power and have applications in immunotherapy as well as targeted drug delivery. Immunotherapy, simple example. So let's say you have a cancerous microenvironment. You build an antibody which will go and bind only to the cancerous cell and then call upon your own immune system to kill the cancer. Similar example in autoimmune disorders. Let's say you design again an antibody which then controls your own immune system and stops them from killing your own cells. Targeted therapy, very small example. Similar example I'll take like cancer. You build the antibody, attach a drug at the tail of the antibody. Now, when it will go and bind to the cancer microenvironment, it will release the drug there. Contrary to, let's say, chemotherapy, where the entire body is affected, right? Every fast growing cell is affected. Similarly, autoimmune disorder, immunosuppressants generally suppress the immune system, thereby hampering the health of the individual. So antibodies are great, huge molecule, great business potential actually. Did $25 billion 2024, Keytruda, and actually most of the top drugs are actually antibody based drugs. But then why are they so, please, next slide. Why are they so difficult to find? Not like small molecules, right? The numbers are very, very less. There must be reasons to it. Well, the biggest reason is to get these antibodies, it's very, very difficult. Classically speaking, of course, it takes a lot of time, which is why we are here with the solution. 2 to 4 years to just get the drug to even start your clinical trials, which is again 10 to 15 years. Imagine the amount of time that takes to get to a drug and the billions of dollars that are wasted, multiple stages of failure. One of them being you would produce these antibodies in biological systems, right? Now, one of the key areas now you have to focus on is to convert this biological drug to a drug, which can be mass produced, can be stored in suboptimal temperatures. A lot of failures again happen at that stage. In order to mitigate that, please next slide, we've built an AI platform. Now, this is how our entire pipeline looks like, where this part is computational. To us, the input looks like a target protein, let's say cancerous protein, or for autoimmune disorder, which then goes in as an input. We generate antibodies which can potentially go and bind to the target, and then we do a bunch of drug analysis. Like I said, everything that we design using our platform are all drugs to begin with, so that we don't have to fall into that vicious cycle of trying to convert a biological molecule to a drug molecule. This is where the computational stage ends, and then we screen for binders. So in our industry, actually nothing can satisfy or prove your case point with just AI. You have to do it at the lab scale. So you do a high throughput experiment to figure out of all the candidates that the AI churned out, how many did actually bind to your target. And post that, we do extended drug developability analysis. And then at the end of it, what we receive, we'll then take the top candidates for clinical trials. Next slide, please. Now, we build the AI platform, and we just don't talk about the accuracy of it, because we proved it in the lab. So we tested our AI platform with a couple of targets, and I'll focus on one of the candidates that I've shown here, G4I47. Now, this was built for TNF alpha, which is an indication for autoimmune disorder. Now, what we saw is when we trained, what we did is we took our AI platform, we removed all the data set, all the occurrences of TNF alpha from the data set, and all TNF-like antigen from the data set as well, and then trained the model from scratch. Now, when we give TNF as an input, we want to see if the model has not seen TNF alpha ever, is it still able to produce binders for it or not? And this graph on the left-hand side essentially shows you that this candidate that I'm highlighting is actually a binder. And we found binders, which was a very good success story for us, because that means you don't need the target data to be present in the training data in order to generate from scratch. The graph on the right hand side is even more interesting. So when we got a good binder, we wanted to test, does it have function in it or not? It just couldn't be your binder, right? So what we observed is when we increase the dosage of our binder, gradually the cell death decreased. So it's an autoimmune disorder, which means your immune system is killing your own cells. As we increase the dose of our candidate, the killing of cells, immune system killing its own cells, gradually decreased as well. What that means is our candidate is not just binding to TNF, it is binding exactly to that point which is required to stop the immune system from killing its own cells. So we saw binders as well as function. Please, the next slide. And we could prove our hypotheses that we do not need any prerequisite target specific data in order to generate sequences, generate candidates for any given target. What that also means is, I'll touch upon how we are building it. So we are building an AI platform which can generate you can stay in that slide. We are building an AI platform which can generate data. And it's a platform that we've designed from scratch, of course, built on existing mathematical principles and trained from scratch in-house. So this is not a pre-trained model where we are fine-tuning for a specific target, which is where the target dependency comes in the industry. For each target, you have to retrain again and again. That's not our case. A couple of more disclaimers. It's not LLM based, and we don't use agentic AI. Next, please. So in this industry, solving for antibody designing or protein design in general is treated as a very difficult problem. So how did we solve it, at least till the success point that we've had so far? We have found that there are four pillars, according to us, for our success. The first and primemost being identifying the right data. Now, antibodies in our space is a long chain of amino acid, which folds to maintain a very minimized, energy minimized state. So there are two kinds of data for us. One would be a 3D structure of the protein. The other is a linear sequential data, which is similar to your language or text-based data. Now, the structure data has more nuances. For example, let's say the first and 100th amino acid sequentially very far apart from each other, but might be right next to each other structurally. That information is not present in the sequence data and only can be found in structure data. Second thing, what we are trying to design, given our target as an input, can we generate an antibody as an output? So what do we need? We need antibody antigen complexes. Now, antibody and antigen complexes have more nuances to it. Here we know that, let's say, one amino acid on the side of the antibody is interacting to exactly the other amino acid which is found on the antigen side, and that is only present in the structure data, cannot be found in sequence data. On the flip side, the data volume is very low. It's low volume scientific data. So how do you train a generative model using such low volume of data? Flip side, sequence data, very easy to do sequencing, experiments are easier, and we have millions and billions of sequences. Do we throw that away? Absolutely not. It has a lot of meaning associated to it. The language of protein, like the language of humans in our English or any other vocabulary, is present in these sequences. So what we decided is extract what you can and learn about the language of protein from the sequence data and train the structural complementarity, sequential complementarity using the structural data, which leads to the next point. How do we now make use of the low volume data? Now, right representation and right architecture goes hand in hand. Low volume scientific data cannot just be thrown into a generative network and expect it to learn whatever it can, which is why you have to represent it with a mathematically transformed representation, which is closer to the problem statement that you're trying to solve. And it is a very rich representation. Per data point in our mathematically transformed version is has ample of information which is missing in just the raw 3D coordinates of each and every atom in space, right? So what we did in our case is, from the raw structure, we transformed into graphs. And when we created graphs at each and every node, we could pack it with a lot of features. At the edges, we could pack it with a lot of features. So that gave us a richer representation at the atomic level. And then we coupled it with the right architecture. So graphs, we need graph neural networks in order to learn. And then essentially what you do is you train using the transform data, see whether you are able to learn what you wanted to learn. If you did not, go back, tweak your representation, train again, tweak your architecture, and this cycle continues till you reach kind of an equilibrium where you are able to extract the meaning that you want to from your low value volume scientific data. One point to obviously emphasize here: if you have low volume data, testing for diversity is very important. If your data is not diverse, it's impossible to train a neural network using that kind of a data. The fourth and most important for us is feedback cycle. In our industry, again, like I said, nothing works if you just have an AI platform, needs to be validated with wet lab. So having the capability of validating the solution each run is essential for us. And when you do the validation, two things are obvious. One is you've proved your hypothesis, you have positive binders. The second that nobody probably talks about is the negative data. Actually, we've learned the most that we know about the field today from the negative data that we had. We know the reasons that they did not bind, and that is what went into the transformation as well as architecture when we kept on redesigning it. Next slide, please. So the two pillars of our architecture, one being graph neural network, like I briefly spoke about. So the transformation that we do is, this is how our input data, raw data looks like. The red part is an antigen and the blue part is an antibody. They are binding in 3D space. This is what I was talking about, right? It's obvious that this is the part where it is binding. Now this gets transformed into two graphs in 3D space. The left-hand side red one is again the antigen. The blue on the right-hand side is the antibody. Now, when you have a graphic graphical representation, you have a lot of scope to pack informations like putting edges strategically between the two nodes which are interacting, or even putting edges for supporting node, which is supporting the interaction. You could do a lot of scientific research on it and have your customized, completely customized data built like this. Next. The second pillar of our architecture is the generative component. In our case, we've used diffusion. Now, very broadly speaking, diffusion has two components. One is forward diffusion, the other is reverse. In forward diffusion, you take your data and continuously keep adding noise step by step till you reach a point where it is your noisy data. Doesn't mean anything. And at the time of reverse diffusion, you take your noisy data and gradually, step by step, start removing noise till you reach a point when you have been able to regenerate what you started with, the original data. And of course, you put a cost function and calculate loss on top of it to then over the time of training to then optimize how your architecture is able to regenerate closest to your original data. In our case, I will just request you slightly use your imagination. It's not an image for us, it's graphs, right? For us, what do we do? Like I talked about the nodes, which is packed with features. These nodes have the crucial information that we are trying to generate, right? What are we trying to generate? We are trying to generate an antibody and we want to see where does the atom lie? Or we are trying to generate which amino acid should be there in order to cause an interaction. So for each of these crucial informations, we take an input graph and we start adding noise to these information at the node and edge level. And when we do that over time, when we get a graph which is noisy, each of these data points are close to your Gaussian distribution. And then at the time of reverse diffusion, we can start with a noisy graph, sample a nice noisy graph, and then condition it with the epitope. So we want to design an antibody for a given target. So when we condition it with the epitope and then gradually start removing noise, we ideally should end up with a graph which is closer or similar to the input graph. And when you do this over your entire data set, several epochs, you end up trying to being able to successfully regenerate what you started off with. Next slide, please. So in a nutshell, this is how our platform will work. We will start with the structure of an antigen, and then perform the mathematical transformation, get the graph. Then our deep learning model kicks in, which now generates graphs which are structurally as well as sequentially complementary to the input. And then whatever comes out, we then filter based on drug parameters and other filters. And at the end of this stage, we take all the candidates to the lab to validate whether they were actual binders or not and whether they were functional or not. So these are the different kind of antibodies. Don't want to bore you, but this is what is present in you and me, called a monoclonal antibody. This is what is present in camel alpacas. They have a far superior kind of antibodies. There is just one chain called heavy chain. We have two chains, heavy and light. Why I'm referring to this is the therapeutic industry now can work with these parts. So this part at the very top is called a variable region. This is the part which actually bind to the antigens. So that now can become extracted and become your single domain antibodies. Antibodies that you and I have two variable domains, light and heavy, which then now can be created as fabs with the 4 domains here, and 2 domains, very heavy and light, can be joined with a linker, which becomes scFv. Now, why did I speak about it? So it's not just the antigens that we've created a generic platform for. Please, next slide. We can design them all. So it's not a specific model for a, let's say, single domain antibody or a fab or an scFv. Whatever our clients want, whichever configuration they need, we can generate it for them. And I have data to show. Next. So these are the few generations from our platform. Here I'm showing fabs. So the red indicator here is the antigen, which comes in as a feedback input for us. And then the blue here is the ground truth. Essentially what it means is it is its partner in nature that is present in the structural data. And the green part is our prediction. As you can see, the prediction that we did, of course, it was not in the training data, is very similar to the ground truth that existed, barring the regions, the loopy regions where actually the interactions happen, which is great because you want to capture structural complementarity. It has to be similar, but it can't be exactly the same. It's generative in nature. Otherwise, where will the diversity come in? Similar thing on that side. Another example. Next slide, please. Yeah, so this is a single domain antibody. Again, even if it is a single domain, we can still capture the structural complementarity, and that is an scFv. And when we tested the sequence level data, meaning the candidate that I spoke about, even though structurally the complementarity was very similar, the sequence was very different. What it means is, even though the sequence that we generated is different, we are still able to get binders. Again, essentially, it means the sequential complementarity is also captured well, which can only be tested in the lab. I'm come to the end of my presentation, but I do want to talk about responsible AI. It is very different for our industry, AI, compared to any other industry. For example, our pipeline, they can only be accessible through closed networks for clients and deployments, and only authorized individuals can access it, which leads to accountability. Each and every user activity is monitored for future audits. We do have transparency. So the neural networks that we have, they are all trained on tangible scientific data, and the fact that I stated, right, something is removed at the time of training can be easily traced back. Next comes reliability and safety. Again, a crucial thing in our industry. Nobody has to trust blindly what the accuracy of our AI platform is. Everything that we hand over is lab validated with tangible real world data. And of course, we are compliant with the ICMR ethical guidelines of AI in healthcare. The founding team and the leadership team, like I started off with, fully led by women. My co-founder has done her PhD in biological sciences from here, NCBS TIFR, and my background is in AIML. Previously, I have been part of Grey Orange, one of the core tech teams there. And then recently in our leadership team, Dr. Abhishek Mathur has joined as CSO. So he had been our advisor since 2021, and he has led leadership teams at Amgen, Enzene, etc. Our core team is also well balanced. Like our founding team, we have core expertise on the biological side with biological scientists in biochemistry, cancer biology, protein engineering, etc. On the computational side, again, we have AI/ML engineers as well as software engineers who can build mathematical algorithms, pipelines, work with very critical scientific data. And then it's a very young team. All of us are young members. Most of the computational team came fresh out of college. And we've built, I'll say, so again, I'll just highlight for this room, the biological team, 4 out of 5 members are women. In the field of biology, there's huge representation of women in deep sciences. No bias required at the time of hiring. Of course, at the computational side, I do see a lot of potential, but in our company, as a fact, we still need to hire more women. Um, that would be it from my side. Happy to take questions at the end or right now. Thank you.
Thank you, Trisha. That was a deep dive into biotech.
I think, are we breaking after this?
We're actually going to just take 1 or 2 quick questions.
One or two quick questions. Please hold on. Please come back to stage. I think that you'll need to address a couple of questions. But besides that, I think a couple of startups are here, and I saw a policy recommendation by somebody saying that more data and compute is to be made available. But just for the benefit of the audience, right? The government of India is offering 38,000 high performance compute at subsidized rates right now through the India mission. Highly encouraged to go and apply for that. And even with the in the AI course platform, which is the data sets, models, toolkits repository, and the integrated development environment platform, we are also going to sort of integrate the IDE with high performance compute more than Kaggle and Hugging Face. So that is also something to build quick prototypes is something that I think this room will really benefit from. And a lot of these foundational models and a lot of sort of actors, including, as I had said earlier in the morning, Respin, Cispin, Vani datasets, ARTPARK, MeitY datasets are already hosted on AI Course. A lot of startups who are being funded have open sourced some part of their sort of data sets. I understand competitive advantage is very important, but I'd again call upon everybody to sort of contribute older models or models that they can open source onto the AI Coach platform, also data sets for that matter. Thank you.
Okay, any questions for any of the 4 speakers? Just waiting for any questions. All the speakers are here, all 4 are here. Okay, we'll just do the
just call the speakers on stage.
Dr. Vaijayanti. Okay. Thank you. Then we have Ritu. Yeah.
You can just say that we don't.
So Sona. We have Trisha. Okay, photo. Yeah, please.
Just a quick photo.
The moderator also.
Yes, definitely.
Yeah.
Thank you so much.
We'll just take a quick 5-minute tea break. We request everybody to assemble back here by 11:55. Thank you.
It's okay. Yeah, close. What's the order? So, what do you want to say? What do you want to say? What do you buy?
I don't have any of those introductions.
Just see, basically tell your demand. What's the you'll get in trouble. Yeah. The only thing I say is having short of yeah. Questions also give a best.
Which audience? Who was audience?
Yeah.
Oh, so she's in. Sorry. Okay. So you are Sanskriti, you are Manu. Who would like to go first? Which order you want to have? So what do you like me to say? Let's define.
Yeah, he's just, there's some people waiting in the washroom. Sending them back. We'll have to give it.
Thanks for coming. So we start. Yeah. So let's start.
Requesting everybody to please settle in. We'll be beginning. Welcome back, everyone. For our next segment on frontiers in AI research, we will hear from some of the brilliant student researchers here at IISc. I'd like to invite Professor Shubhada Agarwal to introduce the students and chair this session. Professor Shubhada Agarwal is an assistant professor in the Department of Electrical Communication Engineering at IISc. She has been a postdoctoral researcher at Georgia Tech, Carnegie Mellon University. She completed her PhD at TIFR, Mumbai, and her undergraduate degree from IIT Delhi. Her accolades include the Inspire Faculty Fellowship 2025, the Sarojini Damodaran Foundation Fellowship 2022, and the Google PhD Fellowship in Machine Learning 2021. She has also been recognized as a rising star of STOC 2023 and as a US Junior Oberwolf Fellow 2024. Her research spans applied probability and sequential decision making under uncertainty. Over to you, Professor.
Thank you everyone for staying back for this session. We have three wonderful speakers for our next session. Let's begin with Sanskriti, who is an ML engineer at ARTPARK. Yes, over to you, Sanskriti.
Sorry, does this? Yeah, you can use it. Hello, good afternoon. Like she mentioned, I'm Sanskriti. I work as an ML engineer at ARTPARK. Specifically, I work on building the speech input and output pipelines. But today I'll talk more comprehensively about what we do, why we do what we do, and some impact that we've had. So it's a quite grim statistic, but a woman dies in childbirth every 20 minutes in India. And for every woman who dies, there are 20 more who suffer lifelong ailments. Only 20 to 30% of pregnancies belong in the high risk category, but high risk pregnancies are responsible for 75% of perinatal deaths in India, which is the maternal mortality. Oh, no, it's okay. This is why Arman, which is the NGO that we work with, and ARTPARK, in collaboration, have built a chatbot for ANMs. Why? Because ASHA workers and ANMs are the frontline workers who provide healthcare to these pregnant women. And they often are overworked, undertrained, and they lack access to information sometimes when needed the most in high risk situations. Which is why Arman has developed a two-pronged strategy for serving pregnant women and to reduce this maternal mortality rate. One is informing women and families themselves. So starting with pregnant mothers, providing information to them. And the other is training and supporting ASHA workers and ANMs. And that is what I will be talking about today. And the goal, of course, is reduction in maternal and child mortality. So we have already developed our system. We have about, we are live now. And some of the challenges that we've observed while building the system is, well, these are the three main challenges which impact the most. One is latency. Of course, users prefer low latency. They prefer the conversation to be far more quick, conversational. They can get feedback quickly. But LLMs, especially the big models with billions of parameters, are often quite slow. Then there's audio. So like it was already mentioned in one of the earlier presentations, audio is a huge want or a huge preference for users. But unfortunately, we don't find the kind of audio usage because our models are quite bad. Indic, ASR, and TTS models are not quite at the level that English models are at. So they struggle with Indic accents, and Indic TTS systems often sound robotic or often have other constraints like latency or just formatting. And the third is evaluations. Because we work with high-risk pregnancies and with medical information, we cannot just put anything out. We have to do thorough vetting of our responses that we're sending. And for that, we rely on doctors and medical officials to sort of evaluate the model, generate multiple rounds of answers, have that vetted to make sure that our system is within the guardrails, within the information that we would like to give them. And of course, government approved. So that is a very time-consuming process because it requires a medical professional to be there sitting and reading all these answers, evaluating them on the multiple criteria we have, such as actionability, interpretability, comprehensiveness, factual accuracy. So that is a very time-consuming process. And as a result, sometimes development and pushing things out can be very slowed down. Um, but we have developed some solutions about which I will talk a little bit. So latency. When we first piloted in, actually launched in April, our text input and output through WhatsApp was about 25 seconds at latency. We have since, in the last few months, cut down our latency to under 10 seconds for response time. And for audio, our input and output latency was 50 seconds, but we have since reduced it to 17.8 seconds. This was done through three primary focus areas. One was prompt optimizations, so making sure that the model prompts are not too bulky and they actually are doing what we need them to do. Second was using smaller models where possible. For some tasks, we don't always need to use large language models. We can use smaller language models, and one of those, and using those really helps cut down on some latency. And the third is just using non-LLM approaches where it's possible. So for formatting and for certain string manipulations, we had initially started with large language models because there was a lot of uncertainty and we were still getting user feedback on what their preferences are, how they want the responses to be formatted. And so in those sort of ad hoc areas, it's okay to use an LLM. But now, over the last few months, because we have more user feedback, more insight into what users prefer, we have migrated to sort of using more just string-based approaches because we don't need to use an LLM and we don't want to spend time in that API latency. Can we? The third is, of course, sorry, the second was in audio input and output. So like it was earlier mentioned that numbers like word error rates are not always the most accurate representation of what is going on. For example, we've tested multiple models and state-of-the-art speech recognition models that are commercially available. The best WER we got for our use case was 35%. We then fine-tuned our own model, and we have then gotten a 35.6% error rate. Quite comparable. And you would say, why do you need to fine-tune if you're getting a very comparable error rate with like commercially available models? And that's because if you actually look at the transcripts, the question that the user is trying to ask is what is breach presentation? But a commercially available model, because it lacks that context, because it lacks that medical information, it says bahut breach presentation, which doesn't make sense, which means that the user's query would go unanswered. We would classify that query as out of topic. But when we fine tune with medical data, we are able to sort of bring that to what is rich presentation. Of course, the spelling isn't perfect, but these are the kind of errors that the downstream tasks are able to recover from, whereas this breach doesn't really correlate to breach at all. So it would not be recovered. Similarly, for jaundice, this question often gets answered as joint disc or slip discs. And so this is why we fine-tuned, because we want the model to not just have low error rates, but to actually be useful to our use case. And of course, fine-tuning then played, the Vani data set played a huge role. And we also had some data which was medical specific that we fine-tuned on. Similar efforts are underway for text-to-speech. And I would actually like to flag another initiative that is being done at ARTPARK in partnership with IISc and MeitY. Is the CISPIN Hackathon, which is a Voice Tech for All hackathon, where startups and students are invited to submit their TTS models. A data set will be provided and evaluations will be done. Registrations are still open if you would like to contribute to our text-to-speech model. And the goal is, of course, to reduce latency, but also have a voice that sounds like A&Ms and ASHA workers, doesn't sound too robotic, and is able to say the medical terminology that we need. Evaluations. So like I said, WER is not always the best metric, and having doctors to do evaluations all the time takes up a lot of time and effort. So something that we've done internally is developed an LLM-based judge, which we can use to quickly evaluate some of the minor changes that we are making to our system, so that we don't have to wait weeks before we can move on to the next step of development. And so these are numbers from the LLM judge, which was rating our answers on comprehensiveness and actionability and factual correctness, all of the other criteria that I mentioned earlier. And you can see that when the input is the actual ground truth transcript, the answers score quite high. And there's, as with WER, some difference between the model output responses, but the fine-tuned model does slightly better than the commercial model. Things to keep in mind about LLM judges, though, is that judges have biases. So if you use an OpenAI model to test another OpenAI model, it's probably going to score really good, which is why we have tested multiple models. So we've tested OpenAI outputs against Gemini outputs and things like that. So like mixing and matching your LLMs and making sure the judge scores are not biased. You need to evaluate the judges themselves. Once you've built your LLM judge, and if you have had the luxury of having human annotators, human evaluators test your answers, then it's always good to correlate them with the human scores to see if your LLM judge is even useful, because otherwise judge scores can sometimes just be ad hoc, which is why I say that LLM-based judges are very good at qualitative analysis, so like sort of indicating yes or no. But if you ask it to give it a number like 1, 2, 3, 4, it doesn't always do a good job, and it tends to score answers quite high. You would rarely see answers be scored 2 or 3. They would either be 0 or 4 and 5. The other is that they're more powerful when ground truth is available. So sort of in the similar space, when you evaluate your LLM judges, you will notice that when there's no ground truth available, and if you're asking the judge to just score an answer based on some criteria, it doesn't do very well because the results that you get are sort of not very interpretable. It's more useful when you have a ground truth query, you have some data, such as like a knowledge base that you can pull from, and then you ask your judge to evaluate, hey, is this answer correct based on this query, based on this knowledge base? And that just sort of makes your LLM judge more powerful. Sorry, that brings me to impact. So we have gone live in April, like I said. Since we've gone live, we are now with about 2,000 health workers across 7 districts in UP, Telangana, and we are also going to be piloting in Maharashtra. We have about 10,000 ANMs on board with us. 98% of the responses were rated as satisfactory overall by ANMs, so we're very happy about that. 70% of ANMs have access to the chatbot, have asked at least one question, which means that we have a good usage. And since launch, yeah, we've answered over 15,000. I think that number is actually closer to 20,000 queries now. But we have answered all of these questions with a 98% satisfactory response. And yeah, our chatbot works in 3 languages, Hindi, Telugu, and Marathi currently. Yeah, thank you. That was my presentation. I would like to quickly give a shout out to my team. So Jigar Doshi, he's the director of machine learning at ARTPARK. He's our team lead. That's me. That's Sid and Soumitra, who are fellow ML engineers with me at ARTPARK. And of course, Arman, the NGO that we work with. Amrita is their product lead. And Parina, Nitesh, lovely product managers. And Vaishali, who plays a very crucial role in evaluations because she's our subject data expert. Thank you. Oh, and Nihar, but I guess I forgot to put his name in here. Thank you.
Thanks, Sanskriti. In the interest of time, we'll take the questions at the end. Our next speaker is Madhuvanti, who is a PhD student at the Department of ESC at IISc. Over to you.
So hi all, I'm Madhu, and this is my work on processing and interconnects. Uh, so So if you look at any ML processor or any processor architecture, you'll basically find three basic elements. One is the compute, second is the interconnect, and third is the memory. So all three of them interact with each other in different architectures in order to develop your processor. Now let me break it down into a more simplistic way. So if you look at a GPU or a CPU, which is commonly used for computing, you'll see that you have a memory element, you have a compute element, and they both communicate with each other. That is, the data moves between both these elements through an interconnect or a transmission channel. So here the role of an interconnect is passive in nature, meaning it is only used for transmission and it doesn't do any computation. So we call it an active element if it is actively involved in the computation process. And now let us dwell deep into the role of interconnects in computing. So here we can see that the role of interconnect is that it adds latency to the system, because when data moves from one point to another, there is an inherent latency that is involved in it. And secondly, interconnects are also lossy in nature. They introduce jitter, they introduce clock skew. So all of these different attributes are basically a nuisance to any processor designer. And also they are also the main cause of an energy bottleneck. Why? Because in the current day, computing elements consume computing data consumes much lesser energy when compared to communicating data. So from I took this from a research paper. So this research paper says that communicating data across a 25 millimeter square chip consumes 80 times more energy than computing the data. So if you look into these systems, the energy utilization, that is the ratio of the useful energy that is actually used for computing divided by the total energy, which is the compute plus the transmission energy, is suboptimal. It is very close to zero. And interestingly, in data centers and in high performance compute systems, the interconnect systems that we have, such as the Ethernet based interconnect systems, which is a very popular choice, have also been trending. They've also been developed. A lot of work has been going on in that particular field. So the current Ethernet switches can now support a data rate of 51.2 terabits per second, and they work with an energy efficiency of 10 picojoule per bit. So now these interconnect systems only make your large scale data centers and high performance compute possible. Now, in contrast, let us look at the human brain. Now, in the human brain, the axons and dendrites, which are the neurobiological equivalents of interconnects, have been found to perform certain linear and nonlinear operations like low pass filtering or coincidence detection and so on. So, the effective energy utilization of the human brain is one. And we are nowhere close to the utilization of the human brain when you compare it to the existing GPUs or high performance compute systems that we have today. So we ask an interesting question. What will happen if we use interconnects for computing? And if we use interconnects for computing, what kind of computations can be done with them? So we look at three major fundamental computations here. First is sorting, delay, and data loss. So consider a physical interconnect. Now, based on the length of the interconnect or based on the material properties, if I'm going to transmit data from one end to another, there is going to be an inherent latency that is involved. So interconnect can actually delay data. Secondly, let us say if multiple interconnects are sending data through a common transmission channel, whichever data got sent first will be received first. So therefore, interconnects can sort data in time. And thirdly, if an interconnect can only handle a certain bandwidth of data, if I'm going to send more data or data at a higher rate, then there is obviously going to be data loss because due to congestion. So now these are three different computations that can be performed using the inherent properties of an interconnect. And therefore, there's not going to be any hardware overhead. So based on these different computations, we have come up with a computing algorithm that is very much different from the conventional way of computing. So the conventional way of computing is you have a neural network, you have synaptic weights, and you have an input vector or a feature vector, and you do matrix multiplication is a basic computing operation that we perform. Whereas we have redefined the way in which computing has to be done based on the computational properties of an interconnect. And that's why we have called this whole work as processing an interconnect. So we have developed a different neuron model, and we have developed how we have to build a neural network using them. So the synaptic weights that you have in a conventional neural network are actually now mapped to synaptic delays that we'll be using in a network. And we have tested this neural network and we have tested them on different standard image classification tasks, and we achieved the state of the art accuracy. And the next consequence of the work is that we have actually mapped this to a highly optimized ethernet switch which supports different ethernet protocols. So now these ethernet switches in a data center, and to communicate data in a proper way such that congestion is met, or the output data rate is maintained, they follow different ethernet protocols or traffic shaping protocols. And we can map the different computational primitives that I just described previously to an ethernet protocol. So your ethernet switch now becomes your neuromorphic processor or an event based processor. So this so now how what happens if your ethernet switch now becomes your processor? So as I described previously, an ethernet switch is a highly evolving technology. Why? Because in order to support the large scale data centers and high performance compute that we have in today's world, this particular technology is trending or evolving in a much faster rate. So the capacity of the current Ethernet switches is doubling every 2 years. The energy efficiency numbers are improving at a much faster rate. So if you see the current 51.2 terabits per second switch, it can actually support a 71 billion pi square neurons and can consume around 1.7 kilowatts of power. So when compared to the existing neuromorphic processors like IBM Blue Gene or a Spinnaker or IBM Strunorth or Intel Lohi Point or Hala Point, which consume around 10 to 100 kilowatts of power to support just 1% of the human brain, we are able to significantly push the power number to a much lower value. So maybe the next revolution in AI actually lies in the way we envision interconnects for computing, or we envision the way in which ML architectures and processors have to be rebuilt. Thank you.
Thank you, Madhu, for a very interesting talk. Our next speaker is Shri, who is a PhD student in the ECE department.
Hello all. Today I'm going to talk about artificial intelligence for oral cancer screening in primary care India. Next slide, please. Can I use this? Yeah. So to begin with, why is oral cancer a problem? Specifically, oral cancer is an Indian problem because India accounts for over 1/3 of the world's oral cancer. And most of the oral cancers are detected at late stage, where the survival rate is less than 20%. And one way to improve this is to detect oral cancers early. But the problem lies in early detection because there is poor access to specialists in the rural India. And coming to the healthcare workers or the ASHA workers who help in oral cancer screening, they are overburdened. And secondly, their efficiency is not good enough. They're not able to look at the oral cavity and tell whether there is some suspicious lesion and should they be referred or not. So, in order to improve the efficiency of the ASHA workers, we have come up with an AI solution, and I'm going to take you all through the development of the AI. So my talk is divided into 3 parts, where I'll first talk about the development of the lightweight AI for edge device, and then how we transitioned the AI model that was developed on a GPU to a mobile environment, and then finally the interpretability of AI. Next slide. So basically, for developing the AI model, we got data from Biocon Foundation, who were generous enough to share about 30,000 images, which were labeled by different oral medicine specialists. Each image had a tele-specialist diagnosis, which were further classified into the non-suspicious class, which is in green, and the suspicious class, which is in red. Next slide. Just to look at some of the examples, the bottom right image is an example of a non-suspicious image. The one above it is a suspicious but a low-risk image. And the leftmost image is a suspicious high-risk lesion. Next slide. Yeah, so because we were envisioning to have a point of care device, we could not use heavy AI models, which are usually used in all the medical applications, where the parameters lie anywhere from 50 million to 100 million parameters. So our search space was restricted to models that had roughly about 5 million parameters. These were the models that we experimented with. Looking at the data, because it was a population scale data, it inherently also represented the prevalence that was there in the population. Therefore, we saw only about 16.5% of suspicious class in our entire data set, whereas the non-suspicious images constituted 83.5%. As we are all aware, this leads to class imbalance, and also this would need more techniques to help AI learn the positive class better. Next slide. So the methods that we tried to mitigate class imbalance were sampling-based methods, where we tried to randomly, we tried two things here, random oversampling and random undersampling, but random undersampling helped. So I'm just going to explain about it. So here what we did is we randomly undersampled the majority class to match the count in the minority class, and this did help us improve our performance. And then the other method was loss function based methods. We tried different loss functions such as focal loss and weighted cross entropy, but the one that gave very good performance was weighted cross entropy. Here, basically, the logic was whenever the model misclassified a suspicious image, we gave a higher penalty, therefore nudging the model to learn the features of the suspicious class in a better way. So these are the results. The base out of all the models that I showed a couple of slides before, mobile VITV2 was found to be having a good performance. So I'm just using those results. Baseline mobile VIT had roughly about 75% average sensitivity and 90% average specificity. But with the weighted cross entropy loss functions and some augmentations such as horizontal vertical flips and random rotation augmentations, we were able to push the average sensitivity by 10% while losing about 4% average specificity. But if you look at the best model, we were able to achieve roughly about 87% sensitivity as well as specificity. So the highlights, class imbalance significantly affects model performance, especially sensitivity. But there are techniques such as weighted loss functions and data resampling techniques, which will help us overcome this. We were able to achieve, as I just mentioned, roughly about 85% average sensitivity and specificity. One thing to note here is, in a recent study that was published in Nature by Birur et al., they reported that the field healthcare workers had only about 60% sensitivity and 78% specificity in detecting a lesion. So as we can just compare AI in with respect to the current ASHA workers and the frontline health workers, AI has a strong potential in oral cancer screening. Now that we have developed the lightweight model, but it still sits on a GPU, we have to now translate it to a point of care device, which is a smartphone. So I'll just quickly tell what are the challenges and how we were able to overcome them. Yeah, so there are two challenges. The first challenge comes from the data set itself. So here I'm displaying two graphs, which are the red, green, and blue histograms of the data set that was used to develop the model, the Biocon 30,000 image data set. And then as part of this study, we also collected about 1 lakh images from 9 sites spreading across 6 states in India, just to validate the algorithm that we had developed. So that histogram that I'm displaying on the right shows the red, green, and blue profile of the primary data that we collected. As can be seen, the profiles look very different. And because of the difference that is coming in from the data, there was a dip in performance of the model that had only seen the developmental data set. So the dip was specifically seen in the specificity as well as accuracy, and this was a problem. We had to handle it. Next slide. The second problem came from the devices that were used to capture the data. So the Biocon data was captured sometime in 2011 to 2013, which was roughly about 15 years ago. And then the kind of devices that were available at that point of time and the way how images were stored was completely different than the way how we do it now. So just to show one quick example, the way how images were stored earlier on the phone and the way how they were displayed to the user when the image was read was quite the same. But now there are other metadata that influence the way how images are read. One quick example, although the image, can you, no, it's fine. So if the image is, although the image is stored this way, when you read the image gets rotated based on the metadata, and that would be the image that the model would be looking at. Because of these new features that have now come up with the data that we collected, and we were going to validate our model on the new data, we had to handle these issues as well. So as a solution to both of the challenges that I just mentioned, we came up with a technique called as white balancing, where we kind of normalize the effects, the color effects that were coming in from RGB, and we sort of put them to have a mean of about 128. And then to handle the rotation issue, we came up with EXIF-based augmentations. Using both, we were able to get good accuracy as well as and sensitivity and specificity. So if we just look at the two tables, I am showing metrics for the best model on the secondary data, that is the Biocon data, as well as the primary data, that is the data that we collected as part of the study. We were able to get roughly good performance metrics. Finally, okay, we have the AI. We were able to successfully put it on the phone and still get a good performance. But why should somebody even trust AI? Because it is a medical application, inducing trust in the tool is very important for large scale clinical adoption. So I'll just show a quick example on why can we even trust AI. So the first image here is an original image. And I now like to point at the third image, which has a black annotation mask that has been put up by a by a oral cancer specialist, where she thinks that that area that has been marked in black is the place where the lesion is. And the one in the middle is a GradCam heat map, which we have generated to just get some sense on what region the model is looking at to arrive at the decision. And if we compare both the annotation mask and the highlighted region in red, they both align perfectly. So this kind of heat maps and the alignment with specialist annotation mask ensures that, okay, AI is not just making some random decisions. It is looking at the regions where the remote specialists or the oral cancer specialists are looking at. Yeah, so the three key takeaways from my talk is that AI has superior screening performance as compared to any ASHA worker, and therefore it has a very strong potential to be included in the oral cancer screening program. And as an edge AI application, there are many issues that come up with. We just can't stop with developing an AI model that works well in a GPU, but we also have to translate this technology to a small compute device such as a smartphone. And finally, models have displayed good interpretability, therefore ensuring that our decisions are made by some things that are very similar to what a human is looking at. Yeah, thank you. Just to end with, I would like to quickly show, this is the app that we have developed along with ARTPARK and Trivius. And this is the app that I was talking about, which we use to collect the data from different parts of the country. Next slide. Yeah, so these are the 9 sites where we went live. We wanted to collect 12,400 participants, but we were able to collect over 30,000 participants, amounting of, I think, 1.9 lakh images. I think the largest data set that we have gotten in India till now. And this is the award that we received for this solution at India Mobile Congress, the Best Education Institute Award for Arogya Aron exhibit. And these are some of the photos from our field visits. Thank you.
Thanks, Tejasvi, for a very engaging talk. I would like to invite all the three speakers of the session on stage for, I guess, for the Sorry. Yeah, Sanskriti.
Thank you. Thank you. Thanks for the nice job. Thank you.
Thank you, everyone. Yeah, I think that closes the session.
Thank you, speakers. I would now like to invite Professor Govindan Rangarajan, Director, Indian Institute of Science, to please come on stage and share his remarks.
Thank you for inviting me. So it's a pleasure to be here. I think this is a very important topic, a very timely topic, and I'm happy this being taken up, and it's also part of the pre-summit events for the AI impact event that's going to happen in February in New Delhi. As we all know, AI has had a big impact, and I keep telling my colleagues and students that we need to be prepared for it in educational institutions, because educational institutions are going to be very highly impacted by AI, and not just students using it for assignments and so on, but also more importantly as a very useful tool for research, for accelerating research. So more and more, researchers have started using it to accelerate research, and I think that is going to be the way to use it going forward. So I hope all of you, become familiar with all the AI tools. Create your own tools. Create, maybe companies which create new tools. So there are possibilities are endless going forward. And even though one need not buy into the hype that is going around about AGI, the artificial general intelligence, and so on. Even without that, I think as of now, it's a very important tool that all of us can use to our benefit. Whether it is to understand papers, whether it is to, start proving theorems in mathematics, or whether use it to, suggest new drug combinations, whatever you are trying to do in all these areas, it has been at least shown to have some good effect. So with these few words, let me thank the organizers for asking me to say a few words. I'm really happy that this event is happening here. Thank you.
Thank you, Professor. We now move to the final segment of our event, a panel discussion on building the pipeline from lab to last mile. Please join me in welcoming our moderator for this session, Ms. Sangeeta Gupta, Senior Vice President at NASSCOM. Ms. Sangeeta Gupta is the Senior Vice President and Head of Strategy at NASSCOM. She works closely with the Executive Council and has been instrumental in shaping the direction of India's technology industry. Having been with NASSCOM since its early years, she has led major initiatives such as the India Leadership Forum, the Strategic Review, and the Product and 10,000 Startups programs. She now leads NASSCOM's AI and Deep Tech Charter. A strong advocate for India's digital economy, Ms. Sangeeta has played a key role in strengthening industry-government collaboration and advancing India's global tech leadership. She holds a master's in economics from the Delhi School of Economics and serves on the board of IIT Delhi. Welcome, Ms. Sangeeta.
Okay. Good afternoon. Good afternoon and welcome to everybody here. Thank you so much. We are at the last session of the day, but we'll promise to keep this interesting and exciting. I'd like to invite my panelists to join me on stage. Professor Chandra from IISc, Rohini Srivatsa. She's been a leading figure in India's AI sector, having worked in very, very illustrious companies, and you heard her this morning. Professor Soma from IISc. And Sheila. So it's very interesting that we have a group which is two leading people from the academic world, Rohini from the industry side, Sheila again from the industry side, who's now transitioned to being at ARTPARK. And we hope we can get this session to get you some specific insights on how do you think about lab to market to the last mile to create true impact that a challenge like AI by her will look to build out. So as we've got settled, I'll kick this off. Maybe we can start the first segment. Each one of you represents role models for people in this room, both who are watching us virtually as well as in the room here today. I'd love to maybe in a couple of quick minutes tell us about your story of how you have done this transition from getting something that you were passionate about, taking it forward, and maybe what are your messages to people who are attending here? So Professor Chandra, if we can start with you.
Yeah, I think this is on. Yeah. Yeah. Thanks, Chiru and ARTPARK for this invitation to be here. And thank you for the question. So I've been working in the area of bioinformatics for, I think, 25 plus years now. So the main point of bioinformatics is to make biological problems computationally tractable and to ask a computational question out of that so that, the advantages are very clear. I don't need to talk about it. So that you utilize whatever data that is there and what you can generate and ask questions to get deep insights and make it faster and so on. So moving into AI as AI evolved was an automatic thing for us. And of course, I've had the privilege to collaborate with people like Chiru, and it's been an enriching experience being in IISc and learning from colleagues and students and so on to move on in this journey. So as we were doing that, we realized that there were many opportunities for translation. So most of us basic scientists don't start with an eye for translation. So this comes somewhere automatically, organically it emerges. And when you see that, it started feeling that it's your responsibility to make that happen, not just writing the research proposals or not writing a publication, that this has the potential for diagnosis or it has a potential to be a drug and so on. Said, why not try that ourselves? And again, in this ecosystem that we are in, we got a very good encouragement and we have a company incubated in the a startup incubated in the campus. We call ourselves HealthSeek Precision Medicine company, which is a precision medicine and health systems company. So what we are looking at is to translate some of the findings from our own discovery from the lab to a product, mainly diagnostic to start with. Of course, drug discovery is something that we have deep expertise in. Going forward, we might move into that. So one of the things that we have, in an advanced stage right now is a tuberculosis diagnostic marker, which is a host-based marker, unlike a pathogen-based marker, so which works with blood rather than the sputum, which is very difficult. There's many advantages of that kind. So that's at an advanced stage at the moment. And it does use AI in components. So I think where we differentiate from many people is to combine domain expertise, biological science domain expertise with AI and bioinformatics tools as necessary to come up with perhaps a lightweight architecture or perhaps AI powered decisions in parts as we go forward to get the final product. And yeah, it is. I think I will come back
I
to
have some
that
follow-up questions for you. But,
yeah. So
but
this is
if
the
I-
journey, and I think I'll stop here for now. Yeah.
But Professor Soma, if I can move to you and ask you, what has been your journey and how you've thought about from lab to market, what is really, your learnings around the way?
Yeah. So, hi. Um, I'm a faculty in the electrical engineering department. So, I work in the core area of computer vision, ML, AI. So, primarily the research directions that we are looking at, which are closer to, what might be useful for translational research, is there are so many models which are being developed, whether it's the traditional models or it's the foundation models. But majority of them, we can't just download and use it for our application, right? We need to not only fine tune it, that's one aspect of it, but as we deploy, we might come up with newer challenges. For example, uh, you know, uh, I think one of the speakers were talking about domain changes, right? The kind of situations where your data might be captured, that might be different from what is available in the training data. So as and when you deploy, you need to update your algorithms without really having access to large amounts of data. So that is one of the key areas in which we are working on. And other than that, though our primary expertise is on images, now you really can't rely on just one domain. You have to look at all kinds of information sources, say, for example, whether it's image or audio or text and so on, and incorporate all the information for your task. So this is, my background. So coming to the part where we started thinking of translating. So it's not really an industry or a company, but it's primarily through collaborations. So I'll talk about one or two of them. So one particular application that we are looking at is fake news detection, which I think we all know and understand that it is a very big problem now. With the huge development of AI, generating fake news has become very, very easy. Whether it's manipulating images or giving an image and generating text, giving a text and generating images, all of these have become really easy, and it's almost impossible for even a human to identify whether an image or a data piece is actually real or fake. So that is one of the areas which is of current interest immensely, and we are close to developing a pipeline. Obviously, it will go in testing phase, but it's not our company. It's through a government project itself. And through that, we are thinking of actually taking it out to users and seeing where it can help. And as a country, if we can use it and take it forward.
Thank you so much. Rohini, if I can move to you, you've seen research in industry, you've, looked at partnering with academia, you've done a lot of work by at least being on government committees. How are you seeing this whole journey and, especially what interests you and excites you the most?
You're referring to women and
I mean, broader, I think, we'll come to the women part, I think, but the broader theme about lab to market,
okay.
to creating the real impact, right?
Yeah. I think, see, in India, in particular, the R&D ecosystem, and I've been part of the DST world for many years as part of the NMICPS and then the National Quantum Mission, etc. I think one of the things which has been lagging and perhaps is changing a little bit now more with places like IIT Madras, IISc, etc., is the cross fertilization between academia and industry. Because if something is developed in the academia as early stage, the ability to take it to different levels of TRL and then think about the product market fit and think about the commercialization of it. I think that's where we've faced challenges, but I'm seeing some shoots of really good success happening there. I think that needs to continue. Um, I think also the and part of it is getting started as part of the whole ANRF work that's happening is the private sector in India, their participation in innovation. While there are enough GCCs and multinationals, I think the private sector in India is still quite underfunding research. Their ability to be part of the journey is also equally important because they are the ones who understand the India market context, and they're being able to help academia think about the applicability of problems to products early on is one of the important parts.
So Sheila, if I can move to you, right? You've seen the industry world, now you're really helping both startups in the art park world. How are you seeing this journey?
Okay. Yeah. As Sangeeta, you mentioned my background, the majority of my professional years I have spent in the industry. While in the industry, the applications of AI, I got involved in that from the domain of computer vision. While in ETM systems, while we were working in the area of audio video processing, um, using computer vision and machine learning and building AI-based applications was one of the domains. The challenges we faced there, the non-technical challenges are, if not more, almost the same as the technical challenges we faced. Because being in the industry, there is always a need to make sure that the products you deploy, there is a buyer for the products that you develop. You just don't, it is not just an engineering aspiration that you feel there is a technical problem here, I solve it, but then there has to be a market, there has to be a buyer for it. And the effort that goes into developing the product, the companies expect multifold returns on the investment that goes in. So, with this as the background, there was a need to make sure that there is a market for what we are going to develop. Not only that, but also the solution that we provide, the precision, it's very important to meet the expected precision. It was very interesting to hear when Anurag mentioned that for the contest that you have, you start from the POC. That is very, very important. So before we can conceive a solution, we need to make sure what TRL level we are. And equally important is the study on the market. And many a times, as people who do the market research know that things are not predictable. Okay, we do make an extensive market research, but then the predictions that we can make need not necessarily be, or most times are not necessarily right by the time the product development is complete. So this is what I would like to highlight. Okay, research stage is one story, but once we reach a POC stage, it's very, very important to have clarity on the market, what market we are going to address, what performance expectations are there for the market, and is our investment going to meet that need? And also the performance expectations, is our solution going to meet that? Maybe we can talk about it a little bit later, but one thing I would like to highlight is while there's a lot of important support that is given to the startups, it's very important that a similar support be given when a product is ready for deployment. I think the effort needed in development is not more than the effort that is needed in deployment. So support at the deployment stage can also benefit in making sure the solutions reach where it has to.
And that's a much harder problem to solve. But maybe if I can stay with you, Sheila, and you talked a lot about understanding the market needs and building for that, as opposed to only looking at a great product that has been built in the research lab and the marketing or the commercialization of that is unknown. For researchers that are building out, or for startups that are building out their solutions, what should be a mechanism for feeding this information? Because when you are building out, you think you've done your initial research, you think it has a market, but how do you find that product market fit and your core customers? How do you figure out who and what to build really?
Yeah. Okay. I would answer this under three headings. The first one would be being connected to the industry and being connected to the end users of the product right from the beginning is very, very important. I think if we look at some of the success stories, I think even before the companies have conceived what is it that they are going to build, they would have done a survey of the end users and understood the pain points. What are the pain points that the user, what is the problem that I'm going to solve for the end user? Very clear understanding of that will be very, very essential. That is one thing. Or to summarize in a single sentence, being connected to the end user, that could be even the some of the industries which are catering to that segment. It could also be that.
saying they should be almost a co-partner in the development process.
Yes, yes,
So
yes.
that you
Yeah.
know who you're building for
Right,
with something. So
right.
you have your first POCs identified.
Right, exactly. The second one would be, see, any serious product development takes time. Development takes time. So throughout the course of the development, has the market needs changed? Having that understanding is also equally important, because we can go back and get enough examples in the history that we start with something, but by the time we are ready to put it in the market requirements have changed. So being plugged in or continuously being aware of how the market requirements are changing and suitably adapting our roadmap is equally important. And third, to simply say there is no single process here. This is the judgment and the having the pulse of the market throughout is essential in my opinion.
And I'll come back and ask you later on any suggestions on how to address these issues. But Professor Chandra, if I can go to you, right? As you were looking at it from building out the product from your lab, right? How are you facing some of these issues that Sheila spoke about, including, and I know what are the other things? Is it about IP management? Is it about understanding product market fit? Is it about getting access to the right technology solutions that are needed? How are you looking at what are the big or what are you facing maybe as you are thinking about converting your product to your research to a product? What are the big challenges you're thinking?
I think very important question. So these are huge challenges, actually. Some of these terms mean different things to different people. For us researchers, understanding the end user, like what is the use case, is very different from what the market requires. We perhaps may not start with looking at it from a business angle. We just look at technologically, is this the correct fit? Is this the best solution among the solutions that are available? That's how my mind would be working. But then when you go to your market, so they're looking at the cost and the temperature, all the practical aspects of it, which are, of course, important. So I think we need a balance of the two things. I don't think we have found a perfect answer, to be honest. But going forward, I think is, who does all of these things? If you are good at the initial discovery and the initial POC stage and moving to a prototype, should you also be good at going to the last mile yourself, or should you collaborate? Obviously, the answer means, it feels that collaboration is the best way forward. But then the ecosystem is such that one is expected to go all the way to the last mile. You can do that, but it's at the cost of many other discoveries that you could actually do. So I think actually for the policymakers that are here, so it would be really useful to somehow nurture an environment where you connect two people, which may not happen at the right time and the right place. uh, there must be a system where this is done more seamlessly. I think that would benefit many people. So this will help people cross those multiple valleys of death that are out there. So you have reached one stage, it is extremely good, but then there is nobody to receive that. In a spectrum of activities, multiple people, multiple organizations are required. So if that next person or next organization is not present at the right time at the right place, then you see a valley of death. So that somehow as a country, I think we will have collective advantage and collective fitness if that is nurtured in some form and that gap is filled. So that's what we're seeing, because we are able to take one product forward all the way through, but then we have 10 others sitting with us. Yeah. And so how do you reach out to partners at the right time? Like who is really interested, who is able to receive it even though they're interested? So
I think that's a huge gap also that I think most people on this side of the industry don't even know what kind of research is happening, what is the kind of products that are being built out. But Rohini, maybe you want to comment on that, on saying how can we bridge this gap, right? I mean, and building out another online marketplace is not the solution, right? So any thoughts that you have on how we can bridge this huge gap? Because if we don't do it, we'll be just talking about it, right?
Yeah, I think, I think, there are, like I was mentioning in my earlier comment, I think there are pockets where it is working. And I'm looking at the likes of IIT Madras, IIT Bombay, to some extent Kanpur, IISc. I think we need to learn and replicate from that. And if I draw a few learnings from those, right? I think the engagement of industry, and not a generic term, but domain experts who are vested in those particular startups, models of co-investment, co-innovation. I think some of those, and then helping getting the venture funding, because see, venture funding when it comes in, I'm not saying necessarily every startup should go for venture funding, but they ask you the tough questions. And you are then, as a startup founder, you are forced to think about the product market fit, the scale fit, the business ROI, which you may not think early on if you don't get that involved. So I think, to me, when I saw, for example, the NMICPS, we had 25 innovation hubs. ARTPARK was actually one of them. And, they started in 2019, right? And I saw the different hubs come about. Then, became a translation and etc. 4 hubs have formed, etc. And I see the ones that have done well, and they're not necessarily the IIT Madras, etc. They're like IIT Roper, right? Some of these have done very well. The learning things from there is that they have been aggressive in terms of partnering with industry. They have been aggressive in terms of not just doing processes, which means I run this program, but I really look at outcomes. I really look at number of startups, not just number of people skilled. So to me, I think the ability for researchers to create it, what's in it for me, for an industry to come in, for a partner to come in, and NASFORM I think Atul and others, you and others have been playing a big role in that. But I think there's a lot more potential for really good ideas, really good talent to see that scale that a startup aspires for. I think we're just seeing a very, very small tip of what's possible, but to me, those do provide some learning mechanisms for scale.
So Professor Suma, if I can come to you on the same question on, you heard from Rohini on what does the industry or, the funding agency expect. But from a researcher perspective, what is your expectation of how do you think the collaboration should work? What can we do to drive this better?
So I think as a researcher, as a faculty, right, working with students, it's maybe a slightly different thing. One of the major challenges we face is to, even if we collaborate with the industry, right, not every work leads to, say, publications, right? And for students, that's very important. So I think as a faculty, it's very important to be able to take a problem and take out the part which is the research and which can lead to publications, and on the side it can also lead to something which can be translated, right? So I think that's one of the most difficult things that we face. The other is not everyone is very good at, say, market research and doing this study. So I think what is already happening that can happen at a much larger scale, that is each of these or most of these institutes, they have these centers, right, which kind of at the institute level, they know much better as to what are the expertise of their faculties. So if uh, they can be the middle factor who can connect the expertise with the final users, that is kind of happening. But if that happens at a much broader scale, then that, I think, can be the linking factor, because not everyone can make this leap, right, from the lab to the market. That is one. But I think one you know maybe easier way is to, when you collaborate, you already know that someone is interested, just that your proof of concept, that has to be done very quickly, because now at the pace as which AI is evolving, right, even a month or 2 months can be a big time before which even models and things can change drastically. So I think collaboration to understand what is important, and even if you have bits of research which you are not doing as part of collaboration, if that can be taken up by that central hub, which can connect you to maybe the relevant industry or the end users.
Sorry, one right. Just see, here is the thing: when an industry, any company, when they come to the table to engage with a researcher, they are investing their time to see a commercial outcome at the end of the day, right? And if the academic person is not aligned with that and their alignment is towards publication, then there is already a mismatch. I think that, there are enough case studies in different parts of the world where this problem is not an unsolved problem. There are enough number of academia who have created startups. So I think the point you're making about, hubs like ARTPARK, etc., and other centers of excellence, etc., doing that is important, but I feel there is a mental model shift also is required. It may not just be enough to have another entity that becomes the broker between two different parties, but I feel there is a there is a mental model shift required, because I mean, any industry is working for shareholders. They are working for a particular timeline for investment, and venture capitalists are looking at a 7-year return on their funds. I mean, that is reality. So I think being able to find that middle ground, where we understand each other's incentives and find where specifically we will come to the middle ground, and that mental model change is very important.
So Sheila, maybe if you want to comment on that, if you are in the middle, how will you navigate these, right?
Okay. Yeah, I have okay. Like Dr. Soma said, not everybody has the right skill set or probably the training to do effective market research. I'm sure everybody will agree, not everybody has it in them to be a researcher in a place like this. It's not everybody's cup of tea. So I feel the hardcore researchers should be left to do research. And because, okay, the reason being, see, while trying to take a product to the market, we are trying to address most times the immediate needs, not the long term needs. But if we focus on that, then the focus that the research team has on the long term, that could get compromised. So I'm more of the opinion that somebody, yeah, like what Art Park does. In Art Park, consciously we make sure that we don't get involved in research activities, because if there is a research that needs to be done, then there is IISc for us. So we look at how the connects can be done on the work that is at a very advanced stage, that is ready to be taken to the market. Is there a connect that we can do between that work, the industry, the startups who can be the vehicles to take the advanced work to the industry? So this is my
No,
thought.
I think that's very well articulated that, sometimes you cannot compromise your long term for the immediate outcomes that you're looking at. But you have to find that balance.
In my opinion, that has to be valued very highly. Yeah.
Yeah. So, Professor Chanda, a lot of the examples we heard or the presentations we heard today were people who were building for the India market solutions, right? Or researching the India market solutions. And many of them are very deep societal impact issues, which will find it even harder to get commercialization. Any thoughts on how do we make sure that many of these very deep technical solutions that are getting built will get adopted? Because at least from the outside, what we see is that you will do a few POCs, not you, I meant, there's few POCs that happen, but then it doesn't get adopted at scale. So are there issues of procurement that we need to address? How do we make this happen, especially for research and solutions that are being built for core challenges at India that are at population scale that we heard today?
Yeah, I think what we heard from the talks today, amazing accomplishments, each of them really, it was really nice, heartening to see that. And many of them were really young people doing it. So it was particularly more interesting that way. Adoption is a very important thing. So I'll tell you, I mean, I wear two hats, but let me tell you my perspective as a professor here of 25 plus years now. Uh, so when the problem is different here, right? When we get students to train for a PhD program, we want to see them graduate at the end of it. So this is somewhat analog as an analogy I'm trying to bring in is an innovation. You want to see it to the market. So in the former, like in a PhD scenario, we don't have the option of whether it will succeed. You let them compete and only the best one wins and the rest can. You measure the success by 1 out of 10 winning. I mean, that is how it is in the innovation industry, right? So for us, every single student means a lot. So we have to make sure. So we work with different strategies, whatever, despite their own abilities or whatever, you get a range of students. We make sure that they graduate, that it's successful at the end of it. I think something similar is necessary in the innovation world as well. Not just, I mean, the traditional competitions and choose 1 out of 100, that is important, of course. But in parallel, I think we must find a solution to see that every single innovation finds its best conclusion in that sense. I think that will change the focus from one thing and how we measure success, whether we have one success at all versus can we get everything successful, everything that crosses the minimum that's successful.
But can you really get everything successful in an innovation?
I think it is possible. If not everything, at least 50% of them we will be able to do that by making these, key connections that are currently missing. So you can't have a generalized solution for every innovation. You need to have something specialized. Perhaps go to AI and for how to do that. I'm not saying it's easy to do that, but I think that's the requirement. So that's what will take many things out of these valleys of deaths that we're.
And Professor Soma, you want to add to this on how do you see this?
I don't know, maybe I just, I think not every innovation can have a final, success story. But having said that, I think not every innovation, but one innovation can lead to another, and finally, a series of them can potentially lead to a success. Uh,
But is there a dichotomy with what Professor Chandra said, right? That the objective is to get the PhD student to the final line rather than saying, I only want the top 3 innovations, right? Is that a dichotomy?
but yeah, but PhD students, they have to graduate, right?
They have to graduate. Yeah, I agree. That whole focus cannot go away, right? So
A little, if I may, little analogous to parenting as well. There's no better place for this to start than AI by the women's incentive, the insights into this, I think will be a core component of this.
Understood. So maybe I'll change topics to the AI by her and start with you, Professor Soma. And do you think there are gaps, especially from a gender perspective, that need to be addressed? And what would be your recommendations for that?
From my personal viewpoint, I haven't really faced uh, any specific, what do I say, discrimination or anything very specific because of the gender part.
I think it doesn't intentionality of
Yes,
getting
but
more,
one
right?
thing which I feel generally, again, I think it may be different because of everyone's general nature, is that especially in AI, whenever I'm in meetings, it's usually just me and maybe one other in a whole room of all non-women. So I think many times, maybe not everyone, but it may be difficult to speak out that boldly. Again, it really depends upon the nature of the person, maybe nothing to do with male or female, whether you can boldly say that, okay, these are your capabilities, these are your qualities, what you can make things work, not work. Again, it's purely personal. I don't think it has anything to do with gender as such. But
So Sheila, from an ARTPARK perspective, are you doing something specific to get more women founders? And do you see the need different kind of incentives or special more incentives maybe? I mean, every entrepreneur needs support, but do you think they need something more?
Okay. In Art Park, if you see, there is a very good representation of women in Art Park. Frankly, I do not know whether there is any policy there about this, but our HR person is here. Maybe she can talk about it. But there is a very appreciable representation of women, which is very good. Then I would probably take a couple of minutes to probably talk about like what you and Soma just exchanged. See, I would like to use this forum to share some of my experiences. I did my bachelor's in 84 and I started my 84, 85 and I started my career in 85 in a public sector, Bharat Electronics. At that time, if somebody had asked me, do you see any discrimination? I would have probably said no. But looking back, there have been, okay? I'll give you examples. For example, our customers were defense. Like the product that I worked on, when I joined, it was a very small development team. I was the youngest, the other two were senior male colleagues. So I had to do a lot of hands-on work, which I was very happy about, very proud about. But when the product was ready and it was ready to go for trials, it had to be tried out in aircrafts, it had to be tried in Navy ships. But I never went for trials. Okay, it went to Rajasthan desert, it went to Leh for tests in cold temperature and high temperature. But I never went for trials. And can you believe me? I was not even told that there was a trials.
Yeah, there is an unconscious bias.
It was kind of assumed that a single girl cannot be sent to all these places. Nevertheless, I felt extremely bad. See, please believe me, you are all youngsters here. At those years, right? These were the norms. In fact, like when Soma says, no, maybe it is the personality. I feel no, somehow these things have been ingrained in us. It is like we have accepted it over years. But only now, when I see the younger generation really questioning, I feel very happy to hear that. I feel it's just that it was so ingrained in us that we didn't even think in those directions, which is very wrong. But I really feel happy when the younger generation questions all of that. So, another example I would like to give. This is not as long as it was 85, even in, I would say, early 2000, okay? See, I was the business manager. I was heading a business unit where we were developing products for worldwide market. And there would be need to go talk to your customers, understand what the need is. So invariably travel to those countries. And some of my sales heads were male. And I would see the discomfort when they had to travel. I mean, if there was a travel need, there would be, I could see the discomfort that they had to travel. I mean, if I had to travel with them, you know. So, yeah, gone through all of this.
Some part of that world has changed. I think girls today are very, very.
Yes, yes. Okay, then I would also like to give credit to many of my male colleagues who have, I would say, okay, for one male colleague who was very uncomfortable to travel, like for example, see, there are situations where only two of us had to travel. Okay, so that put the male colleague in a very uncomfortable situation. But for one male colleague, there have been other 10 male colleagues who have been very supportive. So I would also give credit to all those men who have understood the difficulties and have supported.
Well articulated. Rohini, if I can come to you, right? One is this bias, unbiased that we've talked about. But I think more importantly, as we look at AI by her and what lies ahead, how do you think we can provide a much more facilitative, supportive environment with specific incentives if needed? Right, we heard a few comments today about having more community of people where women can exchange thoughts, ideas. We heard about internship. We've heard about collaboration. Are there specific ideas that we can put on the table, flesh out more? I don't expect you to make all the recommendations, but things we can flesh out and submit as a part of this whole AI Impact Summit to the government.
Yeah, I actually want to reflect a little bit on what Sheila just said before I respond to your question. I mean, I look back at 30 years of my career, early years in R&D world, consulting, then last 10 years in CTO. And I think I traversed my career thinking all I needed to do was be the very best. And I think early on, I had mentors, men, who were also very good in giving me that kind of confidence and support. But as I look back, I think the unconscious biases are still there. They are still there. And especially as you become more and more senior, they are still there. Um, to me, when I ask the question as why 30 years later, I'm having to say this, I think the question that I ask myself, how do we make this AI by her the norm? How do we make it mainstream? How do we make it not a side gig, but a mainstream? And I think to me, one of the questions I'm looking at this audience, there just aren't enough men here. And to me, if there aren't enough men here, it's not going to be mainstream. Only few people who are part of the sort of supporting, right? Who are sort of supporting this, others are not here. It has to be mainstream, meaning it has to be like society is, which is both genders. To me, then what that mean that then drives into a few things. It then drives into the few startups we saw. I was so inspired that role modeling has to be shown in mainstream forums. It's not a separate women AI thing that only women attend. It has to be on the center stage. It has to be mainstream, because the problem is the biases are unconscious. They are there. They are unconscious. And the only way you can make it change is by making it normal, everyday normal. So, because it has not happened in 30 years, clearly something has to be done which does this non-linearly. Something has to be done which doesn't say, okay, this will just happen through diffusion. It's not happening as fast through diffusion, which means certain things have to be done which make it mainstream faster. Which means that few things, of course, I don't have all the answer, but few things like, for example, the kind of work that startups are doing, where women are playing an important role, and I'll qualify what I mean by that. They should be, the role model should be shown mainstream, on the main stage. Second, I think the startups, we are talking about supporting women entrepreneurs, which is good, but let's make sure that entrepreneurs are solving to create businesses that scale, not just women entrepreneurs, which means that you're going to have men and women. Women also play an important role. Men also learn that women play an important role, and it's good to be in environments where both have equal roles. And therefore, I wouldn't go and support startups that say only women entrepreneurs. To me, that's creating another bias. I could go on and on, but to me, the thinking has to be, how does it become mainstream?
Yeah. So make it inclusive. It's neither gender here or there is good enough. So I think we got a couple of recommendations, Anna, that on the Impact Summit, we need some women role models on the main stage, not a side AI by her session. I think that's a very well point. I think the whole focus on saying, as you're funding startups, as we create all these fund of funds and provide support to startups, we are making sure that we are providing, we find the best women-led teams, but they have to be very, very commercially successful, as with any other, startup that they may be. Professor Soma, any suggestions from your side as you look at from from many of your students who will go on to become entrepreneurs? Do you think there are any policy interventions that we can provide, the government can provide to support those young students to become successful entrepreneurs?
Yeah. So I think currently there are lots of Yeah, I think currently there are lots of initiatives which the government is taking, right? So I'm not sure if there's anything specifically that's required. Um, Let me just, yeah. So I guess because if you look at number wise, right, they are still much lesser.
So, and I completely agree with the other panelists that at least showcasing them in a much bigger way, right, as role models to the others might be a very, good way to inspire the others also that they can also come like this. And I think these kind of the speakers that we have seen today should, and I completely agree, should be shown in a normal, not specifically for men or women. It should be a general audience.
Totally agree. Professor Chandra, a lot of the stuff that you're building requires a lot of patient capital. It requires deep funding. And I think one of the bigger issues we've always seen in deep tech is that you can get a little money for government grants, but there is nothing very like a lot of money. I know Quantum Mission and a few others, the India AI mission is now doing a little more than that. But and then you have the combination of a woman founder. How do you think we should be thinking about it from a policy perspective?
I think the biggest challenge is consistency in funding, not only for a startup or even for any have a large number of students who are interested in going into industry or start because they have some technology that they can develop further. But the biggest fear or the biggest challenge that they're faced with is, will I have income monthly to support myself and my family? And so how will I manage? So that fear drives them away into more conventional roles of postdoctoral fellowships and then looking for a job in the academia and so on. So I think that must be supported in some form by perhaps a 5-year fellowship. Make sure that they deliver, but then at least provide that minimum support that one requires, after, as it is, PhD is a long haul. So after, I mean, they're easily at 28, 29 in the life sciences area by the time they graduate. That's one of the earliest. And at that stage, if there is no support, then it becomes a problem. So I think that's
I
something
think
that
that's a
could
great
be
suggestion that think about fellowships from at least a 5-year term. Obviously, you do some annual reviews, milestone
exactly.
based,
Yeah.
but make sure they have a visibility that this is, I don't have to figure out my basics, right? So,
Right. Yeah.
I know we're going to be end of time, but Sheila, last comments from you on what more do you think is needed here?
Yeah, just one point I would like to say. See, I see a lot of initiatives by the government center and for nurturing startups, for encouraging at the students level to take up entrepreneurship. Um, while all that is highly commendable, I feel equal importance subsequently because, as we just discussed, taking product to a market, it's a long drawn process. So, and also, I'm sure you know that it's like kind of a pyramidal structure. I mean, let's say for 100 startups, or I don't know the exact numbers, Rohini might know. For the n number of startups, maybe one succeeds. Why is it? Can we change the pyramid structure to something better, like Dr. Chandra mentioned? Yeah. So support towards that, I feel, will be very, very beneficial and will definitely help in meeting the objectives the government has. Yeah.
Thank you so much. This has been a very, very interesting and lots of different ideas have come up. If there's a question from the audience, we can take one question maybe. Okay, we have a question there in the end. You just speak up, I think.
um, I would imagine that it somewhere also creates a tension when you're mentioning that, the businesses also have to scale. But often what we've heard in the AI world is when we are actually, checking for biases or spending money in debiasing data sets, there isn't an incentive enough to do that. So is there a fundamental tension between having more, sort of women entrepreneurs who would, the hypothesis is, then think about these questions of bias within the data sets and the models that are being built, and then those getting scaled and getting the right funding and being successful in the marketplace?
Yeah, I think one of the comments we were making earlier today about fairness and bias in data is only one part of an AI journey, and not just available data, but access to data, collection of data, all of those become important issues to consider. And I think the depending on the domain you are in. So, for example, we saw the thing about oral cancer, right? I mean, is there a gender element there? So, do are women required to think about the design thinking aspect of it? How will that work? Are there elements in terms of usability? So, rather than an afterthought, I would say that thinking of from a design perspective is important. But having said that, I think to your point about there is resistance, I see, to me that, being the business person that I am, I would ask, why is there resistance? Is there no business value seen in that? Right? If there is no business value seen in that, then perhaps the product market fit is not thinking about the audience it is trying to sell. So one has to go backwards to understand who's the target customer and why is there resistance? Because, one has to make sure that there is clear economic incentive to address that resistance. I mean, the world I come from Microsoft until very recently, there was a very strong effort into ensuring model biases, model issue. But again, it is because the brand is one of the things that has to be protected. The brand is not the element that you're looking to protect. Then there has to be more economic, very clearly demarcated incentives to ensure the investment in addressing biases.
Thank you so much for this session, Professor Soma, Professor Chandra, Sheila, Rohini. Really appreciate this discussion, and thank you all for staying back and listening to us.
I'll request Ms. Sangeeta to just hand over the giveaways to our speakers.
Yeah. Yeah.
I would request Professor Chiru to hand it over to Ms. Sangeeta.
It's been an honor.
Thank you so much. Thank you.
I will also request Professor Chiru to hand it over to Ms. Anna.
Thank you so much.
Thank you. Yeah, photos are good. Thank you.
Thank you so much. I would now request Professor Chiru to just deliver the vote of thanks.
Difficult question. 2 o'clock lunch, and I'm standing between lunch and thank you. So it's absolutely been a privilege and honor to listen to some of the things. So as I was listening to some, especially the panel discussion and the things which our students were doing and more importantly startups are doing, I think I have to hold our good friend Anna to this, that we should have a minimum a day-long program. IISc is open for it. Whereas Madam was saying that a startups focus, and we can also push. There are many things IISc can offer, and which you can bring more men in the room. For example, hiring pitches. So I think we should do something like that. It's a huge educational for me. In many ways eye opener, and would love to have these conversations going. But for now, I guess we have to go for lunch. Thank you.
A couple of quick announcements. We will do a group photo right in front of the building downstairs. I request everybody to assemble there. From there has been transport arranged to take you to the lunch venue. Our volunteers will guide you. Thank you.